scholar and researcher who has contributed significantly to multidisciplinary fields such as image processing, digital signal processing, VLSI design, RF system design, and machine learning. His extensive expertise and dedication to advancing engineering knowledge make him a truly inspiring figure. It is my distinct pleasure to introduce our extended resource person, Dr. Kinde Anelefante, currently serving as an associate professor in the Faculty of Electrical and Computer Engineering at Jimma Institute of Technology, Jimma University, Ethiopia. Dr. Kinde completed his BSc in Electrical Engineering from Bahidar University, followed by an MTech in Electronics and Computer Engineering. He earned his PhD in Electrical Engineering from IIT Delhi, India, under the guidance of renowned professors. His doctoral research focused on low complexity image compression for wireless capsule endoscopy and polydirection in colonoscopy videos, showcasing his significant contributions to biomedical engineering. With a career spanning over a decade, Dr. Kinde has held esteemed positions such as Managing Director of Jimma Institute of Technology and Director of Grant Consultancy and Center of Excellence at Jimma University. Dr. Kinde has reviewed j- leading journals such as PLOS One, Springer's Nature as an Applied Science, and IIT Renewable Power Generation, reflecting his active engagement in academic and professional communities. Let us all give him a warm welcome. Over to you, sir.
Hello.
Sir, we can hear you, sir.
Thank you very much. Thank you for the introduction. Please, would you allow me to share my PPT? So I could know I don't have a permission to share.
Okay, sir, you can now share the screen, sir.
Is it visible? Confirm, please.
Yes, sir. It's visible, sir.
Moving also?
Yes, sir. It's sliding, it's moving, sir.
Okay, thank you very much. Okay, good morning. Thank you for the kind introduction. So my today's topic is on digital twin technology and smart grid operations. My name is Kende, working as an associate professor in the Faculty of Electrical and Computer Engineering at the Jimma Institute of Technology, Jimma University in Ethiopia. I've been working here for almost the last 9 years after completing my PhD. So I have been working on related projects for last 5 years, I would say. Especially, I was involved in Smart Grid Initiative project, which is organized by a consortium of universities from Europe and Africa, which actually aspires to design digital twin technologies for East African smart grid operations, as well as other related projects on this area. So I try to make my presentation quite simple so that those have a deeper understanding of the twin technology and smart grid operations, as well as those who are new to this field could be able to understand my talk. So I try to start from the basics and I'll proceed to advanced one. So this is the outline of my presentation. So I will start from the introduction about digital. So I will start from digital twin technology, and I will focus on digital twin components and architectures. Once then
एक नंबर है एक नंबर में 1 8 1 7
Cooperan.
yes,
1 8
Then करती थी
1 9 1 7 1 9 1 6 1 2 1 6 1 6
so can I proceed? Yeah,
You can proceed. You can proceed.
yeah, other people are also talking on the background. That's how I stopped it. So, yeah, I'll proceed to digital twin components and architecture. Then I'll try to show the applications of digital technology, especially supporting smart grid operations. I try to focus on two case studies, one of which has been done by my student, my PhD student, and the other by the people. Finally, I'll try to conclude my presentation with a brief presentation of challenges and what the future trends in this field will look like. So when I start my presentation on the definition of digital twins, I will. There are a lot of definitions of digital twins. I would like to take the one which has been provided by the Consortium 2021, which says that digital twin is a virtual representation of real-world entities and processes synchronized at specified frequency and fidelity. So as you can see that this definition has two important aspects. One is the digital twin is representing the real world identity. Not only the representation, it has to be synchronized at certain frequency and fidelity. This is very important. The synchronization, frequency synchronization, the required fidelity are very important terms here. Different examples has been given. For example, a transformer digital twin differs from simulated model, for example, which is given by GRE, that it has a capability of forecasting using a time series feedback by using a two-way communication between the virtual and the physical asset. This one, you have a physical asset of a transformer, and we do have its digital twin. So most of the, I will discuss about the models later on, but if you consider the physics-based model of the transformer, generally we do have data which are captured by sensors, that those data are transferred to the model frequently to update our model. Then the model analyzes, or we have an analytics system which analyzes the data which has been sent from the real asset. Then we use machine learning or as other models, of course, and we take a decision what to do next. So that we can actually decide what to do. Of course, send that data, the decision to a transformer to affect the transformer. It could be different. So when you look at the level of data integration at a digital twin, it will be good to compare the previously widely used different models that we use simulation. So earlier, most of the things which have been done were mainly using digital models. So in digital models, we have a manual data flow from the physical asset to the digital object. Okay, that means we take the models of the physical models and we do simulation based on those. So we do have a manual data flow in the digital models, whereas in digital shadows, as you can see, we take or we get data automatically from the physical object to the digital twin or the digital object frequently, not vice versa. Okay, but the data from, sorry, the data from only goes from physical to the digital. Okay, only one way, so automatically, manually. So anyways, but if you look at the digital twin, I think I missed this part. The data flows in both ways. The data flows from physical object to digital object as well as from digital object to physical object. Actually, I missed. Sorry, this curve was supposed to be in that way. Anyways, the data moves. Information communication is both ways, an automatic or a manual way. Mostly. So if you look at in simple terms, the components of digital twin, we do have physical world, we do have a digital world. So we need a communication layer that connects these two worlds through different communication layers. So they share information from physical world to digital world and vice versa. That is how the information sharing proceeds in two-way communication. When we look at the historical background and the evolution of digital twin technology, the idea was conceived quite a long time ago, especially in aerospace mission, especially when satellites are launched in layer 9, started from 1917. In those missions, in the aerospace missions, digital twin concepts were widely used to model the spacecraft, of course. Then the major shift came in around 2013, where Professor Michael Graves from University of Michigan came up with digital twin concept of theoretization. He came up with, actually, he called it digital mirrors. Digital twins. He came up with a theory regarding the digital twins, and quite 15 years ago, I could say, digital twin, the word digital twin was defined by NASA, and now it's being used over 40 years now. And now we do have a lot of digital twin concepts and use cases. Its application is expanding now into many application areas. So when you see the digital twin system, we do have certain components. The first one is hardware, and the other one is software. In between, we do have the middleware. So we have the hardware component is consisting of sensors and actuators, which the sensors is the state of the real estate and systems and processes. The actuators impact them. So on the software side, we do have design tools. We do have simulation environments and dashboard to visualize the state of our assets or processes, and analytics tools for analyzing the situation regarding real assets. We do have, of course, the data storage, data processing, and modeling in between. So let's look at one by one. So what do we have in the hardware? Nowadays, the hardware.
Hardware actuator.
So the hardware components, we do have nowadays Internet of Things embedded sensors that can send this information to servers, especially to the software representation of the model. So we do have sensors which are embedded in IoT. And the hardware consists of those things. But the actuators, they of course convert the signals that the system sends to affect the mechanical or electrical parts of the system. And the network in between, of course, we have routers, edge servers, and gateways, since this is the communication platform. So the data management in the middleware, of course, is centralized repository which accumulates data from different sources of the asset. So this platform takes care of tasks such as connectivity, data aggregation, data processing, quality control, data visualization, modeling, and governance as well, and other related tasks. So examples of such a system can be found, for example, in the solutions where common IoT platforms and industrial IoTs provide along with their digital twinning tools. They review these tools and provide along with the digital twins. Obviously, the software components of a digital twin is the one that turns the raw observations obtained from the sensor into meaningful insights. Mostly, this is powered by machine learning or AI models, and it must have very important components like dashboards. Dashboards are very important for real-time monitoring of assets and the real objectives, and it has to provide a way to design for modeling those digital twins, as well as to simulate certain scenarios of the system. In addition to that, we have a digital thread, which bridges the physical and the virtual world. That means it actually interconnects the physical systems with their virtual representation into a very closed loop. So what does this do? Of course, the digital thread as a bridge between physical and virtual world, it collects the data. It also, of course, analyzes the data. It helps us to run the simulations or make the predictions and optimize the system or the production. It makes decisions, and it also gives visual insights about the system. So some of the operations of the digital age are this, which actually helps to bridge the physical and the virtual. So very simple architecture of a digital twin is here. We have a physical space on the left side, and we do have virtual space on the right side. So the physical space, it contains the data or the sensor data. Okay, we could have a data management platform which can actually do like data aggregation, etc. And it can send that to the virtual entity platform based on the request from the virtual entity platform. And the data can be analyzed by virtual entity platform. So the service platform can request service from virtual entity platform, and the virtual entity platform can send a response. And of course, this service can be sent to as a response to the system or the physical entity. So the physical entity. So it's a very simplified architecture of a digital twin. So there are a lot of architectures that you can find in literature. There are 2-layer architecture, there are 3-layer architecture, there are 4-layer or hyper-layer architecture. You know, there are a lot of architectures that you can find in recent literature. But I have chosen this 6-layer architecture of a digital twin, which is commonly used in scalable digital platforms. The first layer is the physical layer, which consists of the physical devices, sensors, as well as the actuators. And we do have data source and controller, okay? We want to control our physical assets, and we want to connect, we collect our data from the physical assets. So this is the data source controller layer. The next layer is, which consists of course, local data repository, where data can be stored and processed in the local platforms, and then sending it through the communication layer. Okay, so our next layer is the communication layer, where the data can be sent to a cloud. Okay, where in the cloud we can have a repository. Okay, where you have storage, and the virtual layer is the last layer, which can manipulate or take the data and process the data in order to get important visual insights for decision making. So this is one of the architectures, but I will provide links to other architectures, which are simplified architectures. If you look at the scale and the scope of digital twin, the digital twin can be designed at a component level, single component level. For example, transformer alone can be, we can design a transformer digital twin. Even within the transformer, you can take single component of the transformer and the digital twin. Then we put together this component, this perform what we call system or a composite digital twin. We have, that means the composite digital twin consists of the assembly of discrete twins, certain number of twins. But those can be assembled in order to form a system. Okay, a system. Then the systems can actually form system of systems. Generally, our topic, our discussion in the letter is going to be about power system. So power system digital twin is system of systems. We do have generation system generally, we have transmissions, we have distribution system. So we do have the digital twin of system of systems in the case of power system. So the conceptual framework looks like, so we do have the digital twin models, which actually communicate with the data. With the data, we have our, the center, we have the data center, right? We do have the data center from the, we have a physical asset or object. The physical object communicates with, of course, with the data. It sends data. The sensors, they send data to the data center. Those data, of course, must be manipulated or analyzed using analytics and goes to our so our digital twin provides services, and the design improvement also can be subjected to the simulation by the digital model. Okay, so this is simple. So, what are the enabling technologies for digital twin? There are a lot of enabling technologies for digital twin. So obviously, some of the technologies, as you can see, are the sensors and actuators are the enabling technologies for sensors for digital twin. And the other one is analytics. For complex systems like power system, for example, we gather a lot of data from different components of the system. So analyzing this complex data requires sophisticated data analytics. So, so one of the enabling technologies, data analytics. The other one is data integration. We have a lot of sensors in many of the complex systems. So integrating those data in a way that can give us meaningful insights is one of the important aspects of digital twin. So data integration is another enabling technology. And of course, visualization is very important. So an operator has to look at the state of the status of the real objectives by visualizing the outputs of the data. So most of the digital twin providers nowadays, they do have huge data visualization tools. Artificial intelligence nowadays is playing a significant role in many of our lives. So artificial intelligence, especially machine learning, plays a significant role also in this way, as it can help us to improve and optimize the systems by analyzing the data. As digital twins need to communicate in two ways, from physical to virtual and vice versa, connectivity is very important. So there has been a lot of argument on what type of communication is required, because the requirement, especially the real-time connectivity challenges, are one of the issues that digital twin has to overcome. As the complexity of the system increases, of course, cloud computing platforms are very important in scaling up digital twin technologies. And of course, with the digital twin and with the cloud computing, cybersecurity will also come very important issue. And these are some of the enabling technologies one has to consider. And the advancement in these technologies are actually which are driving digital twin technology to be realistic in many applications. So one may ask how one can implement digital twin. We have physical assets or physical objectives, a power system. So how do you implement such, or how could you do get the twin, the digital twin? So far, if you look at the scientific literature, you will find two approaches or two solutions. One is physics-based solution, and the other one is machine learning-based solution. So the physics-based solutions are widely used nowadays. And recently, with especially advancement of deep learning models, machine learning-based digital twins are also getting so much attention in the community, in this community. So if you look at the physics-based models, of course, we call this structural models. We do have models which have been already developed, for example, in mechanics. And we have governing equations based on the models developed earlier, simple models, analytical models. We use those models to build the digital twin. Whereas in the machine learning models, we use statistics and data science concepts. That means we try to model the asset from the observation of the data. So generally, what kind of model we have? The machine learning based models is we do have models which can be used to predict output of the system based on the sensor input. Okay, so these two models are actually widely used nowadays. So if you look at this, is a typical physics-based solution of a digital twin. What we have is the physical structure. For example, wind turbine here, we have a measure data, okay, and we have a finite element model. Okay, then we apply the physics. Okay, the physics-based models about the structure or the behavior of the wind turbine. Most of the time, these equations are very complex equations, very complex high-order differential equations, which are not easy to solve and complex to solve, of course, and computationally handy. So we use, of course, reduced order models, and we use model updating in order to generate the digital twins. Okay, so this is one example. So what are the pros and the cons of these models? Okay, one, if you want to design a digital twin of a particular system, so the machine learning based digital twin, so is obviously it is derived only from the data, so you don't need prior knowledge about the system you are modeling. So you are going to have a generate flexible model which can handle heterogeneous data streams, of course. And this you can improve the model over time, like by employing reinforcement learning systems. So, especially for very complex relations and patterns, this is very good at discovering those. Okay? But it has a cons also. The disadvantage of the challenge of finding, sufficient and quality training data. Very important. Okay. So, and the other issue along with this is, their nature is black box. So there is no explanation that you can provide easily for the behavior of these models. So we rely on approximations. So there is no exact mathematics that describe the machine learning methods, and unless we have a very comprehensive training data set, most of the time, the accuracy of these models is poor outside the training data set space. So generally, if the sample space of the training data and the test data, the inference data is going to be different, they perform poorly. So, and they are very bad at also predicting extreme or critical conditions. However, the physics-based models or digital twin models, so they capture the deep existing knowledge base, okay, mostly the physics, already developed equations that govern the behavior of the systems or physical systems. So they have this causal relationship which can provide very easy insight and understanding of the system. So their uncertainty also is controlled by the input and modeling accuracy. Okay, by the input and modeling accuracy. So the model has this is universal validity. That means it can predict any point which is covered by the model, but you don't have that in machine learning based models. So the cons of this model is you need a very expensive knowledge, right? So one has to be expert in that field to come up with this model, and computationally very challenging. So solving a very large order of differential equations is going to be through computational methods is very challenging, and iterative process most of the time and takes a lot of time. So those are some of the really. But if you look at nowadays, both of them are widely used, and we do have now also what we call the physics informed. So those are my sessions on digital twin concepts. So finally, let me say a few things about application areas of digital. So digital twins are applied healthcare, smart manufacturing, innovation. It has been quite a long, even this application has been widely employed in innovation industry. And it was started there, of course. in the energy sector, social media, agriculture, as well as education. So our focus on the subsequent presentation or next presentation is on energy sector. So I want to focus on two important challenges we do have nowadays. This is data taken from one of the references, which shows the world's largest blackout list from 1990 to 2022. As in different continents of the world, there has been large blackouts, and you can see the number of people which has been affected in millions. Okay, in different years has been very varied, but you can see that a lot of people has been affected by the blackout. So blackout and frequent interaction of power has been the challenge of power system operators. One is that. The other issue that has challenged the existing power system is the renewable energy capacity that is being added to the grid systems is increasing significantly. As you can see from the curve slide, okay, especially solar, wind, which are intermittent powers, their contribution is increasing. Right? The wind and solar, they are volatile power sources. They are intermittent. So the intermittent nature of these sources are actually challenging the modern grid system. So as you can see, there are two challenges here. You have lack of reliability, and the other one, an integration of intermittent energy sources into the grid system. So if you look at the history of electric grids, all the way from 1980 to now, right, where it started with the DC transmission system or distribution system, right, all the way to where we are now, where we are using digital twins in electric grid. Okay, so you can see that the next or the current technology is, or the future technology is going to be digital twin. So most of our power system will have a smart grid with digital twin technology. Of course, there has a lot of issues that has really, a lot of technologies have been introduced, like the microgrids in 1950s and the virtual power plants in 1970s. Smart grid concept has come around 2007, and Internet of Energy, okay, has been introduced around 2012. We have now in 2020s about smart grid. So this is how the electric grid concept has evolved over time. So now what we want is more interconnected, more efficient, more secure, and more affordable electricity. So how that can be provided? One solution could be digital twins. Okay, so this is the smart grid framework, which is provided by NIST, National Institute of Standards of USA, of course. So we have, of course, as you know, power systems have generation, it has transmission and distribution. And we do have also market, of course. We do have operations, we do have service providers, we have our customers. So of course, the electric flows from generation to transmission to distribution, then from distribution to customer. That's the old model. But nowadays, we can also generate electricity locally or in microgrid structure, so that we can, of course, have electric flows from generation to customer. And not only that, now the customers also can, or we can also have service providers, generators, which can supply to our customers also can supply power to the distribution system with what we call distributed generation system. Okay, so we do have a very complicated two-way power flow system rather than a one-way old. So what our next generation electric grids look like? So the smart grids should use generally an information and communication technology to gather and act on information such as the behavior of the customers, the suppliers, right? And of course the source. Okay. So this requires communicating between different parts of the system and for improving efficiency, reliability, economics, as well as the sustainability of electric service as per IEEE. So this is really a very good. We have, as you can see here, virtual power plants, we have microgrids, we have internet of energy, and of course we have smart grids, which consist of communication technologies, okay, which gathers information and acts as per the information provided. So how the digital twins play a role in the smart grid? So I mentioned earlier, the challenges of the grid nowadays are mainly of reliability and integration challenges. Nowadays, we have large scale solar power plants, large scale wind farms, biomass plants, and others. And we do have also microgrids. In addition to that, we could have also solar batteries. So on the customer side also, we do have technologies. And even the customers can now generate and using buy-in mechanism scheme, they can also supply it. So coordinating this will be the important aspect of digital twins in improving smart grids. So generally, the smart grids will play in roles where we can monitor and control the grid, smart grid, the grid in the real time. Okay. And we can also provide predictive maintenance based on the digital twins, because the digital twins, as I'm going to explain later, we have models representing the actual asset pattern. So that, okay, we can predict the asset status ahead, which requires maintenance, or so predictive maintenance can be easily we can incorporate digital twins in smart. Optimization is the other role, optimization of the grid operation, because we have information from customers as well as from the generation side. And enhanced decision making, decision can be optimal, and integration of course, renewable energy source. We can also have a higher sense of security by employing digital twins, and the customers also can be engaged in this customer based digital twin. So let's look at grid reliability and resilience. So generally, if you look at the power systems, of course, now with digital twins, the operators can visualize the overall status of the grid. So you have a single view of the whole system. So which allows you, of course, predict as well as act in an optimal way. So a single view of the truth about the system is very, very important for predicting maintenance as well. And when we talk about grid modernization, with especially issues related to global warming, renewable energy integration to the grid system is playing a central role. So, unfortunately, with this renewable energy sources, most of them being intermittent, and with the changing behavior, they impact the customer satisfaction, and they are also challenging to integrate into the grid system. So, the digital twin allows to integrate and proactively monitor the behavior of this distributed energy generation systems and enhances the customer satisfaction. So some of the issues, not repeating, are present. So if you look at a smart grid system with digital twin, without digital twin, it's very difficult to really look at the operation, the maintenance, and safety, the governance, other aspects of the power system in one view. So we need to really manually inspect, or we use what we call the SCADA system, which doesn't have intelligent computing facilities in order to determine the operation, the maintenance, and safety of the governance of the system. Whereas with digital twins, we can integrate the required functionalities into our system, and we can have very easy in determining the operations, the maintenance, and safety as well as the governance of power system. Obviously, the implementation of digital power grid structure is very important for implementing digital twins. So, starting from physical grid all the way to application layer, we need to incorporate several abstraction levels or several levels of grid structure in order to realize the digital power grid, which we can use it as a digital twin. So, for the sake of time, I am not going to discuss in detail this. You can have a look at the details of So a very important thing in smart grid, electric grid is that if when you design especially digital grids, digital twin grids, so far from my experience, there are two types of twins. Okay? One is the asset twin. Okay? What do I mean? Asset twin is that every component, every physical asset of the power system is separately modeled or put as a separate twin. So why this is important is that we can actually determine the life cycle, the status of every asset. We have transformers, we have distribution systems, we have transmission lines, we have generation units. All these units, we need to have one twin for asset. Another twin is for the network, right? So we have two twins in the case of power system. We have a network twin, okay, which shows the network configuration of these all assets and their behavior. So these assets, of course, are part of the network twin. So these two twins, so this will help us to reduce the complexity of modeling the grid. Okay, so in this way, we can have a much easier task of separating the network from the asset. So we can have like a modular structure of designing the digital. So those are some of the concepts I want to discuss. So let me go to case study where I want to show you some of the works which have been done based on the concepts I have discussed here. So the first one is taken from the reference report, which uses a digital twin for photovoltaic power prediction. What do I mean is we have physical space of PV system, and we do have this digital PV system or digital space of PV system. So we want to use this concept of the digital twin in order to predict the power production of the PV system. So it uses, of course, machine learning or say deep learning algorithms. Specifically, CNN and transformer architectures are used in this work. So generally, what is important here is that okay, we have a digital twin which can more accurately predict the power generated by the photovoltaic system, because as you know, it is dependent on the temperature and the sun, the radiation of the sun, etc. All right, so we have a lot of systems, of course. Here, a lot of sensors are involved here. So the digital twin sees it communicates or it receives these parameters, important parameters related to the PV system. It can have more accurate prediction capability. So how it was done is simple. We have the digital space which has been built based on what we call physics-based models, or right. So you can have that. So what we have is we have the physical space, means we get actual measured data, okay, and we normalize it. Then we apply sliding window based approach, right? Then we train the model. Similarly, we do here by comparing the data from the digital space and the physical space. We of course train our model. The difference between the digital and physical model will help us to iteratively train our model parameters. And with that, we're here, the authors of this architecture are able to find highly accurate system. They used this deep learning model, of course, and this is the CNN layer as well. They have used, of course, transformer layer, and they got very interesting results. That means that they demonstrated here that the digital twin-based models are much more accurate than the generic deep learning models like LSTM. So they have shown over here some interesting results as you can. Okay, so this is one application of digital twin in process. Another work was done by my student, so my former student also. So this was as part of our project on East African Smart Grid Initiative. So the idea was in order to dynamically rate the overhead transmission lines in Ethiopia. So, and try to see how much is the utilization of this electric overhead transmission lines. So we looked at, for example, three lines in the capital, they're called the Kombolcha, Sululta, and the Kadeti. These are some of the sorry, you can see, yeah, some of the transmission lines that we have over here. And we observed the transmission line rating for this using sensors. And as you can see, the current carrying capability of this lines is varying from time to time, because the current carrying capability of this line, you know, determined based on several factors like the temperature, the wind, and etc. Right? So based on that condition, as you can see, the current carrying capability of the lines varies throughout the day. Okay, so you can see morning it could be higher because it may be cold, but during sunny days. Because here in Ethiopia we are around equatorial region, so our day is quite hot. So because of that, current carrying capability of the line goes down. So here, what we have used is we have used heat balance transmission line for overhead lines according to this equation. So we have this equation which takes into consideration the heating, the solar heating, the convective heating, the radiative cooling, the magnetic heating, the corona heating, and evaporative cooling. It takes into consideration a lot of components that impact the transmission line. So we actually mounted overhead line mounted monitoring sensors like this, and we used these sensors, and along with these sensors, of course, we have employed LoRa-based communication system, okay, to transmit the data from the sensor to the server. And we applied for machine learning based ampacity, current and capacity of light, to forecast ahead how much my transmission line could be able to carry, how much current it can carry. So we applied different algorithms, and of course, this is where we apply in the capital transmission lines, which are in the capital, which are on 132 kV, 220 kV, 400 and 500 kV transmission lines. And of course, we got a prediction error of very low, of course. Okay. Of course, the prediction error increases. I mean, depending on the time, for example, I'm predicting ahead. I can observe what has been previous and what is now, and I predict 5 hours ahead so that I can plan to use that transmission line certain capacity. So this has revealed very interesting results, of course, that rather than upgrading the transmission line, we can, systematically monitor the transmission line capacity, and of course, we can use efficiently the existing transmission line so that we can use it in an optimal way. So our result, of course, has really showed very interesting results. Our research has shown very interesting results, because the Ethiopian Electric Corporation uses fixed carrying capacity, line carrying capacity. They don't monitor the capacity of the lines regularly, so they have fixed current rating. That means it is most of the time underutilized. So with this, we are able to, of course, propose this technology to the corporation so that they can. So, finally, what are the challenges we encounter when you try to implement digital twin in smart grid? So there are a lot of challenges. The first one is complexity, because smart grid has very, even in the campus level, at the college level, there are a lot of components. The network is also quite complex. But when you look at a national level or regional level, it's very huge. So there are a lot of assets, there are a lot of networks. So complexity is one of the challenges. Okay. And of course, grid vulnerability, grid protection, and integration. Okay, especially integration of renewables is very challenging. Very challenging. And security, right? With everything, for example, cloud-based security is another issue. But the other very critical issue is the communication network. Real-time monitoring requires real-time communication. But with advancement in 5G and 6G, I expect this to be much lesser an issue in the very future, right? So 6G and 5G, 6G could provide much higher communication capability at lower latency. So the last very short topic is what actually the future trends for this is going to hold, or what are the important innovations that will help us to advance the implementation of digital twins in smart energy systems. So one important thing is uh, edge computing, okay? Because cloud computing, cloud is must be very far from the sensors. Sending data from sensor to cloud is going to take a lot of time, delay. So edge computing will be funding, bridging that where the controlling or the monitoring the system is very highly real time. Okay, the real time requirement can be by hand rather than relying on cloud computing system, which is very far and takes quite some time. Edge computing and regarding the complexity of the system design, we could rely on containerization as well as microservices. But pertaining to security, we can of course employ blockchain technology into the smart grid operations, which are nowadays providing highly secure communication and interoperability. And this provides more secure energy system to the community. Those are all the topics I want to discuss today. Thank you very much.
Thank you so much for your wonderful presentation, Dr. Kinde. And now I would like to call upon the participants to raise up their queries by turning on your mic. I repeat, I request all the participants, if you have any queries, you can please turn on your mic and raise the queries. Or else you can post the queries across the chat box.
So I have a doubt.
Yes.
Okay. Sir, the PIN system you told, the sensors and data collection centers are being stored in cloud or somewhere else, sir?
Yeah. So it depends on the system. Yes. So generally nowadays, as you know, you can use cloud or your local server.
Okay, sir.
So
Okay, so what kind of data it will be collecting continuously, sir? Actually, there's some time delays are there or any continuous monitoring system, sir? This is
yeah. So it depends on the system requirement. So the system, for example, the one that we have installed for our transmission lines was this ambient temperature and wind speed, etc. Okay, so we install them. So we configure them as per the requirement of our system. So we configure them per 1 minute, because the system doesn't change quite, like the sun or the temperature doesn't change quite frequently. Even 1 minute was not necessary, but for other systems, it could be very, it has to be very frequent. If you take, for example, in manufacturing, it doesn't. But in the energy systems, especially in line monitoring, the one which we implemented, we were able to take at a very coarser time, because the wind speed, the temperature, etc., they don't change so frequently. So how the variables that we are monitoring, we collected it. Is that fine? The answer to your question?
Okay, sir. Thank you.
And Kinde, I'm having a doubt.
Yep. Okay.
How the power system data can be processed in a digital twin technology? Can you brief about it?
Yeah. So we have sensors, of course. For example, the one I mentioned earlier, a typical example in our case was we have sensors. Let's say at a particular substation, you are getting certain frequency, okay, or you are measuring the frequency, the voltage and the current, right? So you measure this and send it to the sensors are embedded with IoTs. So the IoTs can send the data to the server. So on the server, we do have the digital twin, which has the capability of processing this data. Okay, then based on the analysis, we can send back actuator data. So generally, you have a sensors, you have a communication network, which allows you to send data from the physical system to the twin. The twin, where the twin is the software, like, for example, if you look at MATLAB, even nowadays, even ETAP, the one we use to design electrical networks, they do provide such a facility which has the capability of simulation processing. Yeah. Did I answer your question, sir?
Yeah. Thank you so much, dear Kinde. And participants, if you have any doubts, else we will wind up this session. We will be having next session shortly. Okay. Thank you so much, Dr. Kinde Anle Fante, for giving a wonderful session today. The title on digital twin technology with power system concept is highly interactive and informative. And now I call upon Devadarshini of Tripoli to deliver the vote of thanks to our resource person today.
Thank you, sir. As we reach to the end of this session, I extend my heartfelt gratitude to Dr. Kinde Anlefante for gracing us with his presence and sharing his profound knowledge today. Your in-depth insights into multidisciplinary field and your valuable guidance have been truly inspiring. We are deeply grateful for the time you took to address us and for sharing your academic and professional experience. I would also like to thank our institute, faculty member, and organizing team for their support in making this event a success. Last but not least, a big thank you to our enthusiastic audience for your active participation. Let us take inspiration from Dr. Kinde's outstanding career and contribution and continue to strive for excellence. Thank you and have a wonderful day.
Thank you very much. Thank you. Thank you to all of you.
Thank you, sir, for today's session. And dear participants, after a short break of 10 minutes, we'll be joining for next session of day 7. Please stay connected with the same link. Thank you. Suresh Kumar, sir.
Hi, sir. Can you hear me?
Yes, sir. Good evening, sir.
Good evening, sir.
Sir, let me start the session, sir.
Yeah. Let me share my screen.
Yes, please. Sir, now
Hello?
the screen sharing has been stopped.
1 second, sir. I'm just
Okay.
resharing it.
Yes, sir.
Now it's visible, sir.
Not yet, sir. Please turn on your slide. Move to your slide PPT.
1 second. Now it's visible, sir.
Yes, sir. It's now visible.
Okay. Sorry, we have been using Microsoft Teams.
Okay.
Zoom is not allowed
Okay.
to install in my laptop. So I
No
am
issues.
joining from
No
the
issues,
phone,
sir.
sir.
No issues. Can we start now, sir?
Yes, sir.
Okay, sir. Good evening, participants. Today we are going to have a session. We are going to have a session being presented by Engineer Suresh Kumar, Deputy General Manager, Digital Power, Schneider Electric, Bangalore, and he is going to deliver the session on designing resilient power system for future industries. And now I call upon Purnima Devi to welcome our chief guest today.
Good evening, everyone. I am Deepika from the Electrical and Electronics Department of Sri Krishna College of Technology. I welcome you all to the second session on the day 6 of FDP. It is my pleasure to extend a warm welcome to all of you to today's event. We are gathered here to gain insights from an expert whose journey is a testament to excellence, dedication, and innovation. Our guest today, Mr. R. Suresh Kumar, is an accomplished professional with over 25 years of expertise in application support, customer support, business development, sales, and marketing. He embodies a fine blend of technical acumen and managerial prowess, and his contributions to the field of electrical and electronics engineering are truly inspiring. It is a privilege to introduce our first person of the day, Mr. Ashok Kumar. He holds a bachelor degree in electrical and electronics engineering from the Madras University and a postgraduate diploma in marketing management for the prestigious Symbiosis University Management. Currently serving as the general manager, Digital Power at Schneider Electric India Private Limited. Mr. Suresh Kumar has rich professional background, having worked with renowned organizations like Evisan Railroad, Tyco Electronics, and Emerson Industrial Automation. He is an expert in reactive power management, power quality, energy management systems, and energy audits. With his deep expertise, he has developed solutions for power factor correction and harmonic mitigation for various industrial projects. Additionally, he is certified as a lead auditor for QMS ISO 9000 to 2008, highlighting his commitment to quality and excellence. Today, we are fortunate to have him with us today to share his insight and experience. Please join me in welcoming Mr. R. Suresh Kumar. Over to you, sir.
Thank you, ma'am. And I thanks all of you to spare your time to hear me. So I want this session to be interactive session. I don't know. I'm not facing people in front of me. Normally, when I give a presentation, I want to have a in-face session because there you can see what is their facial reactions, which may tell you that whether they understood or not understood, whether they have some sort of clarities, when whether they need to have some more informations, all these things. So I want some interactions to happen in this session. Uh, so I want to ask a small question before going forward. What is law of energy? Can anyone please tell me? What is law of energy? Hello? Can anyone tell me what is law of energy?
Sir, energy can neither be created nor be destroyed,
Yes, it can be transformed from one form
but
to
it
other
can be
form.
transformed from one form to another form.
Yeah, this is the law of energy. Thanks for doing this, sir. And we have been neither be trained to read this definition, but it automatically came to us. Like when I say Ohm's law, we always have that in mind, like V equal to IR. So we have the definition. Nobody has thought the definition. Like when we ask for Baba Black Sheep, nobody has thought that. Even now we remember that Baba Black Sheep. So that rhymes whatever is there. Similarly, this energy, a law of energy, which states that in this universe the energy is constant. It transforms from one form to other form. That's it. If you're doing any share market trading, if you see, you'll be gaining some money, but it doesn't mean that you're gaining the money. Somebody is losing the money and you are gaining the money. Somebody loses in the market and you are gaining in the market. So this is what happens. The energy transforms from one form to other form. But I'm changing the definition now. You can note down the definition, the same definition. Energy can neither be created nor be destroyed, but it can be transformed from one form to other form efficiently and sustainably. So these two words should be added at the end. So today's scenario needs that the energy, it should be efficient, the energy should be sustainable. So this two has to be put in the laws of energy. So when you say the political laws or other laws, it keeps on changing the evolution, but this electrical laws, whatever is there, it doesn't change. But now when we say the law of energy, it is not a formula or something. So this is applicable for any form of energy, be it a mechanical energy, be it an electrical energy, be it a chemical energy, any form of energy. If you see the chemistry, we have been always taught to prove LHS equal to RHS. I know all your professors want this to be done, right? LHS to be proved as RHS. So we always say that LHS equal to RHS, hence proved. If I do this, then I will get a good mark for the question. Similarly, in a chemical reaction, if you say some chemical is being added, the output will be some chemical. There is no change in volume. There is no change in volume, but the clarity gets changed in between. So, how efficient the transformation happens, how sustainable the transformation happens. This is what the world wants now. Any future design of an electrical system or future industries, whatever we talk about the future, we want efficiency to be put in the place. I can go for a technology. If the technology doesn't brings any efficiency, then no use of the technology. See, when I say mobile, when the mobile things came, 2G to 3G to 4G to 5G, what is the difference between 2G to 3G to 4G to 5G? If the signal is very weak in 5G, the evolution from 2G to 5G doesn't make a sense. Now when it goes to a 5G, the band limit get increased, so the efficiency is getting increased. So any changes or any development that has been done should be efficient. Okay, if that is not efficient, the system will not be efficient, the technology doesn't play an important role. Next point, what you need to have is reliable. If you are buying something, you want that product to be reliable. Say when you're buying a mobile, you want that mobile to be there for next 4 or 5 years. Okay, it should be reliable. When you say reliable, if if the technology whatever you are implementing in a product doesn't make the product reliable, and the product is efficient but it is not reliable, it doesn't make a sense. So efficiency should go in hand with the reliability. This two is must. Then next, one more important aspect that what you need to have is, when you're buying any product, how do you want that product to be? You want that product to be safe. First and foremost thing, you want that product to be safe. Okay, if the product is efficient, the product is reliable, and it is not safe, then also it's waste. So when anything has been designed, any system is designed, or any technology is being implemented in any of the sectors, it should be safe, it should be reliable, then it should be efficient. These three has to be kept in mind when you design any system, any future image. Then the last one more thing need to be added. So this is the three basic pillars which I can say. The last pillar which you need to add right now, if I ask you how many devices you have which is connected to an internet, on an average, you may be having 2 to 3 devices on an average. One is your mobile. By default, it will be your mobile. You may have a second mobile also. Then you will have a smartwatches which is also being getting connected to the internet. Then your laptop or the PC is also getting connected to the internet. On an average, you can say a person is having 3 devices which is connected to an internet. So when this internet connectivity goes and the data is flowing, say earlier when I'm getting the laptop from my company, it was say 10 GB, 20 GB, 30 GB, but now they have given 500 GB. Even the memory is full. I want 1 TB. That is also getting full. My Google Space, which is of 15 GB, is getting full, and they are offering me 100 GB now. Even when I use an 100 GB, in next 1 year it will get full. So much of data is going into this system. So much of data. So what will happen if all this data is being stolen by someone? It's a waste. Then when you design any system which is efficient, which is safe, and then which is reliable, then the data, because the digitization comes in, and when the digitization comes in, you want to remotely monitor the system, you want to remotely control the system. All this digitization comes in, so much of data is going on. If somebody stores the data and then they hack your system, then your system is completely gone. You are putting in efficiency, reliability, and all the other places, but your system is being hacked by someone. All your thing is good. So the fourth pillar should also play an important role when you are designing any system. Okay. Now I will go for an one mantra which you can keep in mind. If you cannot measure, you cannot manage anything, be it in anything. If you cannot measure, you cannot manage. Okay. Touching the sustainability, what is sustainability, sir? I don't know, because I've been asking questions. I want to ask questions, but nobody is responding. Let me see if somebody responds for this. What is sustainability? What is sustainability? Anyone? Because I normally start a presentation to all the students, because I have been teaching students, and then I have been teaching industries. I have been giving a lecture to all the people. I will start only with sustainability, because I want you to spread this sustainability to the people. What is sustainability?
So to meet our own needs.
To meet our own needs. Finish it off, sir. Finish it off. To meet our own needs. Then
To meet our own needs without compromising the any others.
without compromising the future, to meet their own needs on their own.
Yeah, yes, sir.
How you are meeting your needs as of now on your own, you should make the future also to meet their needs on their own. This is the full definition. I want these definitions to be so you can mark this definition with you, because this is the urgent need for a planet. So that's what you can say. It's an urgent need for the planet. So sustainability means it can be your system sustainability, or it can be an this world sustainability. Okay, this planet sustainability. At present, I will just give you a small information in front of you. Climate change, it's a code red for an humanity. Say when you see any movie, I think most of you could have seen a movie called Amaran right now, right? So I just saw the movie in the morning. Okay. They say something danger is coming. They say it's a code red. So the word code red means it's a danger. It's a danger symbol as a code red, they say. So it's a code red for an humanity. What is it, humanity? So we are all humans living here. It's a code red for humanity. This word has to be changed. Actually, I don't want this humanity to be code red for an living organisms on this planet. This should be the actual scenario, because equal rights is there for an other animals also living, other organisms that is living in this world. So it's a code red for an planet, code red for a living organism. So we, as an electrical engineer, so we use an electrical energy. So I will see how we are contributing to this code red for an humanity in terms of electrical. So the energy related carbon dioxide emission, if you say the energy related carbon dioxide, one second, okay, the energy related carbon dioxide emission which is going, so this includes your generation of an electricity, then your demand side, that's an usage of an electricity. If you see, energy related carbon dioxide emission is 30 gigatons of carbon dioxide per year. This is in 2019. By 2024 probably it may be something around 35 to 40 gigatons of carbon dioxide per year. If we keep on increasing this, or if we keep continuing the same amount of carbon dioxide emission into the atmosphere, then in 2000, whatever temperature is there, I'm taking 2000 as a base to 2100 as a base. Now we are into 2024. So 24 years we have passed, and then we have another 76 years in front of us. 2000 to 2100, if you keep using the same, if you are keep emitting the same kind of carbon dioxide in the atmosphere, then our ambient temperature will get increased by 3.3 to 5.7 degrees Celsius, which is very, 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 very dangerous. Okay, even 1 degree increase in an ambient temperature can make a disastrous. Okay, now we are in 2024. Probably we may be in the range of say something around 1 degree or 1.5 degrees Celsius now. With this 1.5 degrees Celsius, we are facing so much of floods, so much of cyclones. We cannot even tolerate. Just think of if we are crossing this 1.5 and then touching this 2, 3, 3.5. Every year, it will not be every month, you will have so much of problem in the universe. Okay. Now, what should I do for this? How should I prevent this? There should be some pledges that should be taken by humans, or there should be some pledges that should be taken by an industries, or the countries, they need to take some pledges. So everybody, it's a responsibility for everybody. Okay, when we take a national pledge, it's not that the nation is going to take a pledge, the citizen has to take a pledge, the community, the state has to take a pledge, the district has to take a pledge, and then the community has to take a pledge, and individual has to take a pledge. If that is not there, it's not a pledge which is being done. And the current pledges are the commitments put by the world. Say I'm saying all the countries, say India has taken some pledge, and then Japan has taken some pledge, US has taken some. With all these pledges, whatever is there, we can able to reduce down 3 gigatons of carbon dioxide. Out of this total emission, we can reduce down 3 gigatons of carbon dioxide, which is roughly it may be 10 to 15 percentage. Okay, with all this, due respect of all this, then your temperature increase of 3.3 to 5.7 degrees Celsius can be brought down to 2.4 degrees Celsius by 2100. But that's not sufficient. You know what is the target of carbon neutral or net zero? You know the difference between carbon neutral and net zero? Any idea? What is carbon neutral and net zero? Anyone, please? When you are taking class in when you are taking a class in your colleges, when you are asking questions, somebody is not answering, how do you feel? I'm feeling the same, you know. What is the difference between carbon neutral and net zero? Either you can tell know or don't know? Hello?
No idea, sir.
Okay, that's good, sir. No, in between, why I'm asking this question is I just want to know whether I am talking alone or the system is live. That's why I just ask you. At least in between, you can say yes or no. Okay, so the carbon neutral and net zero. What is that? Is the you know this greenhouse effect? Whatever we say, greenhouse effect. Is greenhouse effect good or bad? If you're talking about, some people will say greenhouse effect is good. Some people will say greenhouse effect is bad. Both are right. It is good earlier, but it is bad now because the carbon dioxide going to the atmosphere, the layer is getting increased and increased. So the temperature, the heat, whatever is coming from the sun, doesn't get it. It gets reflected from the surface of the earth, but it doesn't go out of this layer because the layer is becoming thicker and thicker. So the temperature is getting increased and increased. So now what people are saying is you need to reduce down the carbon dioxide, which forms that greenhouse layer. So if you are reducing this carbon dioxide emission, then the greenhouse layer will not grow. So the temperature will not grow up also. The temperature will not increase. So this is the purpose of the greenhouse. So when I say carbon neutral, that means that we are talking only on carbon dioxide. When I am talking about net zero includes your methane, then sulfur dioxide, carbon dioxide, carbon monoxide, all these things. So what is that neutral means? Whatever I am giving out, I am subsidizing here itself. So I am catching up the same thing. Like I can plant so many trees. The carbon dioxide when it goes, then automatically these plants absorb that. So it is not going. So LHS equal to RHS. So it's zero, and it is zero. So when I make it zero, then it's called as a carbon neutral. Say our Bhutan is carbon positive. So that means that whatever they are emitting, and they have so much of sinks that it is absorbing this, and then it is also absorbing from the other countries also. Because when I go up in the atmosphere is common for everyone, then they are also doing so. They are a carbon positive. Now India is taking a target for carbon neutral and net zero by 2070. We will be net zero. This is the target for India. So in all the industries, they also taken pledges stating that we will be net zero by 2040. So as a Schneider Electric, we have a net zero as 2040. You can search in our Google who all the industries who have taken a pledge to for a carbon net zero. Okay, now with all these pledges, whatever is coming up, so it is 2.4 degrees Celsius. That is not even sufficient also to live in this world. If we keep continuing this, we need another planet also. So all these studies, whatever we are putting on Chandrayaan and going to Jupiter and then going to Mars, why people are going doing all this research is they want some other planet, because this planet is going to die. It's already started dying. It is going to die. We need to go to some planet, and then we need to see whether the planet is livable planet. Okay, this may not be today's problem, but it's tomorrow's problem. Tomorrow is, it starts from tomorrow till next 100 years, 200 years, 300 years, 400 years. It can go up to 1,000 years also. Already there is a prediction that has been done by 2025. The world is starting its what I call, the world is going to die. It has started the dying. By 5049, the world is going to vanish off. So the new world will start. Okay, now in order to prevent this, or I need to postpone this, when you're going for a cancer treatment, what they do is they give some sort of treatment to postpone your death. That's it. You cannot prevent the death. It's just postponing the death to next 1 year or 2 year or 3 year. Similarly, it's just postponing. So when I am having this temperature of 3.3 to 5.0, it's going to be faster and faster. The dying of this planet is going to be faster and faster. But with all these pledges, I'm reducing down to 2.4 degrees Celsius. So it slowly goes up. But there is a limitation that has been kept, where people are saying that 1.5 degrees Celsius is globally accepted by all the countries all over the world. So that's where this COP29, COP26, COP27, COP28, you can see it in a paper. COP29 is going to happen now. So where people are discussing and they are mutually agreeing that we will limit our ambient temperature increase to 1.5 degrees Celsius. If that is within 1.5 degrees Celsius, then our planet is safe. I can make this planet safe for living for next generation to next generation to next generation. I can do that. So for all these things, what you need to do is you need to go for an 10 to 15 gigatons of carbon dioxide reduction. Now we are at 3 gigaton reduction, but we need to go for 10 to 15 gigatons of reduction. So what are we going to do right now? So as you know, we need only three basic things to live on this earth, or this is the basic needs for all the humans, or it can be any organisms in the world. I need only three basic things. One is the food, the other is a water, the other is an air. So air is getting polluted by carbon dioxide, and land is also getting polluted, and your water is also getting polluted. So now we are targeting only on air, because at least water I can go for some filtration or some methodologies to filter the water and have a drinking water. Or now people are looking on to getting the water from an air itself. Okay, they are taking the water from an air, and then it's drinkable. Similarly, land, you can put some sort of chemicals into the land and make your food now. At least your food can be met right now. But the air, once it is getting polluted, you cannot wear a mask everywhere. There is a movie called O2. If you see, he will be keep on having that oxygen mask with him. If he takes out, he will die. Similarly, everybody, we should have wear a mask only then to live in this world. It is very difficult to wear. Even normal N95 mask, which we wore during our what you call this COVID period, it is very difficult for us to wear. Whenever we find a time, we will remove the mask and take some breath. So when I put a so much of big mask to pollute, to filter out the polluted air from outside, it is very difficult to live in this world. So oxygen, the air, is going to play an important role. That's why people are now looking for an carbon dioxide reduction. So how do we do this in an electrical perspective? How do we design a system to meet this sustainability? How do we do this? We should make it more electric, more digital. What is more electric is, it's not like more electrical usage, it should be green electric. Any system or any design, whatever we are going to do, it should be more sustainable. That means that it should be more green electric, and it should be more digital in the sense, when I say smart, when you are saying that when you have a phone, smartphone, you call that a smartphone. You also have a phone, okay, where you can talk and you don't have an internet connectivity, all the things, that is not called as a smartphone. And this which you are using, WhatsApp, all these things, is called as a smartphone. What is the difference between these two? Both are used for calling. Okay, both are used for calling. That's the basic purpose of a phone, what you call. Both are used for calling, but this gets some data, and then it gives you some data in front of you. The communication becomes faster, the efficient communication, the time lag, everything is big. So it is no smartphones, because it's working smart. So when you, so much of data that you are getting and collecting and keeping with you, then you are smart. You are called as a smart fellow if you know more informations. So when you make it digital, completely digital, then it's a smart. Okay, so electric plus digital will make this system sustainable. Okay, so electricity is the more efficient energy and best vector for decarbonization, and digital makes the invisible to visible. So if you don't know something, what you're doing, you're just going to the Google and searching that. Why Google is so famous now? Because it is making something which is invisible or unknowing to you to a known fact. Somebody is giving information, and that gives you the information. Artificial intelligence plays an important role. Why? Because whatever you are thinking on your mind, it is doing it and giving it for you. So this is making the invisible to visible, and whatever you don't know, it makes you to know. So invisible to visible, eliminating waste and driving efficiency. Digital makes efficiency. More and more digital, the more and more the system is efficient. So any doubts so far, or any questions need to be asked? I will pass now. Sir, Jaiswa sir, any doubts or any clarifications? Because I'm not seeing the chat. If somebody puts a chat or you want to know something, we can put it in the chat.
Sir, no issue, sir. It's a clear presentation going on nicely.
Okay. Now there is a complexity in an electrical network. Okay. When you are saying that grid, okay, or when you are saying an electrical system, there is a complexity that is going on to the electrical system. So what is the complexity? So the topic itself, which is the designing resilient power system for future industries. So you are talking about a design of a resilient system, also of the future. You cannot do this. When you are doing something, it is for today. For tomorrow, it may be different. You don't know what is going to happen in future. That is tomorrow what is going to happen. The technology is evolving in such a way that today one technology, tomorrow one technology. So if you talk about an iPhone was having only 11, 6, 7 or 8. It was there for a long time. But suddenly it get changed. Every year they are going for a new models getting introduced. So the technology is getting changed. And you don't know what is going to happen in the future technology. That means tomorrow what is going to be the technology. So when you are designing the system, it should be resilient. That is right. It should be resilient. Okay. But for future, you should know what is the problem that you are going to face in the future, so that to avoid that future, you should do what in your electrical system. You should know this. If I could have told you that you're going to have a disease called as an COVID, forget the past. If I am telling you that if you are going to have a disease called as an the virus called as an coronavirus, which will have all these impacts. I'm telling you, in another six months time, this virus is going to enter here. What you will do? You will prevent that now itself, right? So everybody will prevent that in such a way that virus will not enter here. But what happened in the past? We have got affected, then only we started doing that. It has become pandemic. Why it is called as a pandemic? Because it is increasing drastically and you cannot control with any of your technologies, or you cannot control with any of your medicines. So that's why it's called as a pandemic. So many deaths, so many infections. So you should not make your system pandemic now. So for this, what you should know, you should know what is the problem that you are going to have it in future. You can incorporate that in your design right now. But it doesn't mean that whatever you are having right now will solve the tomorrow's problem, but at least you are anticipating some problems. So when you're going for an any new projects or something, you will write some FAQs. Okay, FAQs is based on the problem that you could have faced, or FAQs could be based on, it's a frequently asked question. FAQs could be based on the designer. He may think in future, oh, this problem can come, this problem can come, and he will put in FAQs. If this problem comes, contact us, or if this problem comes, change this. Okay, they may be, but tomorrow you don't know what is the problem that is going to happen. So there is a complexity that is going to happen in the grid. So there is a growing complexity in the electrical system. What is the complexity is the traditional model, whatever we have, right? The traditional model in the electrical system or electrical network is generation, then it goes to transmission, then it goes to distribution, then it is going to the customer. So this is the power systems design what we have, traditional power system design what we have. But the new model is evolving because the technology evolves, the new model of thing gets evolved. So what is the new model? Generation, now we're going to transmission, then it has becoming a bidirectional. If you're traveling on a road, okay, if you're traveling on a road, say in same Coimbatore, if you're going for a junction and many people are coming into the Lakshmiville junction, I'm taking a Lakshmiville junction. When this junction is there, many people are coming in, so there is a high chance that there may be some accidents that can happen. Okay, so they are putting some signals there and some traffic police was standing, everything is being kept up. If it's a one way, there is a low risk that people will get an accident if it is a one way. So this is a one way. Okay, and this is a bidirectional way. So that means that there is a junction that is coming, say the grid. Now everything is becoming a smart, the grid is becoming a smart. When you're putting your phone, smartphones, when you're buying in smartphones, no, the grid is also becoming smart, everything is becoming smart and smart. Your components is becoming in smart, your ACs is becoming in smart, your TV is becoming in smart TV, everything is becoming in smart. So the grid also will become in smart. When the grid is becoming smart, what does that mean? So it is based on the demand response. So what is demand and response? I generate some electricity and there is some demand for this power, and somebody takes this power. So based on the demand response, or based on the energy efficiency, or based on your needs. The power is getting generated internally. How do you do it internally? We haven't distributed energy resources, we call it as an, we will use an battery storage system internally, we will use a solar system internally, we will have an windmill internally. Based on the demand and response, we will transfer the source of energy. It gets transferred to, so when this is happening, when I'm not using this energy which is being produced by me, it automatically goes into the grid. Okay, now from the grid I'm taking the, here if you say from the grid I'm taking the power to the consumer level, but here from grid I am also taking, and parallelly I am also injecting to the grid. If I'm not using it, if I don't want, I will also inject it. Okay, this system is becoming a more complex and complex. When the system is becoming a more complex and complex, the topic what we are discussing now, designing the resilient power system, will be more tough for us to design it. So what should we do right now? We should know what is the problem that is going to happen. Then I can make a system which is reliant. I can design a system which is a reliant system. So what is happening? Because of this, there is a paradigm shift. Single source is going into multiple source of power. Then AC is now becoming an AC and DC, hybrid AC and DC. Then simple electrical system is becoming a fully electrical distribution system. Then electromechanical is becoming a digital nowadays. Then centralized is becoming a decarbonized, and centralized is becoming decentralized. Carbonized is becoming decarbonized. What is carbonized is, till now you are giving out a carbon dioxide, thereby burning a coal. But now people are saying that you reduced on the coal, or you are burning your petrol and diesel to run your car, and now they are saying that you should reduce on that. So how do I do that? I do enforce that. So now they are saying that if I am burning the petrol or diesel which is BS4, then my pollution level is high. So they are putting a pressure on the oil manufacturing companies to make petrol or diesel in such a way that when I burn it, it doesn't give more carbon dioxide to the system. So BS6 comes in. The vehicle should be BS6. The fuel should be BS6. No, BS7, BS4, BS8. Every year it gets changes. So I'm putting an enforcement, and now I'm saying that no more diesel vehicles should run in the streets. So I will stop down that. Future it will be like no more petrol vehicle also should be running. So only the electric vehicle should be running. So this is what is going to happen in future. So carbonizing whatever you are doing right now, stop now or reduce now. And then we need to decarbonize. That means that I need to take back the carbon dioxide which I have emitted to the atmosphere. So with all this paradigm shift, there is a two basic needs which has to be met. If I say this thing like electrical safety and reliability or efficiency, 100 years back also people want some system which is safe, reliable and efficient. Even now if you are designing a system, you want your system to be safe, reliable and efficient. These words have not changed in last 100 years. Just think of these three words have not changed in 100 years. Write it. It is not going to change in future also. Everybody wants the system to be safe, everybody wants the system to be reliable, everybody wants the system to be efficient. Okay, this three is going to be the future needs also. So when you are designing any system, these three should be kept in your mind along with the cyber security. Okay, now I have told you the four aspects, right? What are the four aspect is availability. So availability is the reliability which I say. So when I say availability, this is my demanding needs. But for this demanding needs, anything whatever, when you are demanding something, there is some problem also is going to happen. Your demands is not going to be met without any problem. You are going to achieve this demand with some problem. If you're if you want to buy some car, then there is a problem in front of you which you have, that you may not have a sufficient money, or you have to get a loan from a agency to buy your car. So you'll have so much of problems in front of you. If you are taking care of all these problems, then you are going to meet your demands of buying a car. Similarly, one demand, what is the requirement of an electrical system is availability. That means 24 bar 7 the system, power system should be available. But what I have, the problem in front of you, challenging situation in front of you is, India ranks 80th among 137 economics in terms of reliability of electrical supply. So one end you want 24 bar 7 supply, and now our rank is 80th rank. So this is a big challenge I have. My system itself is this way. Then power disturbances in India imposes losses of 4% of GDP. So there is a lot of power losses. If you say the power losses, when you study the power losses in an electrical system, it is roughly coming to almost 35 to 40 percentage. Now it has got changed. For 1 unit of power, what you are consuming at your home, or 1 unit of energy, what you are consuming at your home, I should produce 3 units of power at the generation side. 3 units of energy. So that means 66 percentage is lost. What I am talking about is, hypothetically I am giving saying that it is 50, 40 to 50 percentage, but in practical, if you see, 66 percentage of energy is lost. If 3 units is being generated, I have only 1 unit at my home. So where are we heading? I'm having so much of big challenge in front of us, and I'm saying that I want an 100% availability. It's like you don't have anything and you are dreaming for an aeroplane, buying an aeroplane, and you don't have any money. So this is like, then power outages cost 1,60,000 crores in 2020. It is getting increased and increased and all. Okay, so this is one. Next challenge, what I say is, everybody wants their electrical system to be 100% safe. Okay, I don't want any accident to happen. But if you say the fact, if you see the challenging fact in front of us is, 2,80,000 numbers of electrical fires have been reported every year in India. 2,80,000 fires. When you take any newspaper any day, there will be fire accidents, and this fire accidents, 70% is because of an electrical problem. Then one life per hour is claimed by an electrical accidents in India. So that means that 24 people are dying each day because of an electrical accidents. Then more than 1,000 crore property is getting damaged because of an electrical hazards. Now I want an safety, but I have this problem, this challenging situations in front of me. Then I want a more efficient system. Everybody wants an efficiency, right? So your management wants an efficient professor. Okay. When you talk about any product or any people, anything, they want efficient. You should be more efficient. People are talking about. But what challenges that what we have in front of us is, electrical consumption is increasing by 2 times. Will get increased by 2 times by 2040, and I have only lesser power generation, but my demand is increasing by 2 times. And what should I do? And you are saying that it should be efficient, and you don't have a technology also. Where are we going to head on this? Then 40% of global carbon dioxide emission is emitted from an electrical generator. So if I'm saying the system should be more efficient, then your carbon dioxide should also come down. Then finally, connectivity with cybersecurity. So I told you the formula for your sustainable electrical system is digital plus electrical. This two is equivalent to your sustainability. Okay. When I am saying digital, the data. So the data, it should be connected with cybersecurity. There is lots of hacks that is happening up, and you may not be knowing this in the industries. There are lots of hack is happening. Apollo hospital system has been completely hacked. Then your AIM system was completely hacked. Many industries have been completely hacked. Many of the top-notch industries system is being hacked, and they are asking for a ransom. And if you pay them, then they will release the hack. This is happening on the back. Okay, there is a black dark web that is happening on the back. And if you say the data is new currency. Okay, there is a movie you can say in Tamil, Irumbuthire. This movie you can watch. Actually, when I say some movie names, it doesn't mean that I'm watching only the movie. Something that you need to take from the movie and correlate with your day-to-day problems, whatever is there. So when you talk about that Irumbuthire movie, they say that for one page of Xerox, he will get 1 page of your Aadhaar card. He will get 3 rupees from an hackers if he gives a copy of this to a person. And when you are taking a Xerox, it may be 50 paise or 1 rupee, maximum one, but he gets 3 rupees from an hackers, because for them it is a currency. Your data is a currency for them, and he know how to make money from the data. Okay, from that paper, he will make 100 rupees and he gives only 3 rupees to this fellow. Okay, data is a new currency, and 30 to 50 billion devices is getting connected in 2027. Say earlier, if you say there are 5 billion people, say now there will be an 130, 140 crores, 120 crores of people in India. If you are talking about 10 years back, on this 120 crores, you may have something around 5 crores or 10 crores of devices only, or 2 crores or 3 crores of devices getting connected to an internet. I don't know how you people are feeling. 10 years back, I don't even have a mobile with data. If somebody has a mobile with data, that's a what you call a luxury. I call it a luxury. But nowadays, everybody has 2 GB, 3 GB of data per day. They can use it. So now, if you see, so much of data is getting connected. 120 billion people have 240 billion devices connected to an internet. Earlier, it was only 1 crore or 2 crore. Now it is getting multiplied by 2 times. So many data is going. Where are these data are going? Who is managing the data? How your data is safe? Now iPhone is coming up with a bigger promotions. Why iPhone is giving a bigger promotion and everybody is buying an iPhone? Because people say that my data is safe from my iPhone. Okay. Then 1.7 billion data breaches. It's happening now. 1.7 billion data. It is in July 2019. Now it may be more than 2.53 billion data breaches that is happening. So how are you going to address this four? Okay, you need to design the system in such a way that this four pillars is being met. And now you need to know what is the problem that is in front of you. What is the problem? More and more electronics. So this slide is more important slide. I will just explain this one. Okay, presently 30% of electrical power generated uses power electronics somewhere between generation to end use. Small example I will tell you. If you have an LED lights, okay, LED lights, what is there inside an LED light? Anyone can tell me what is there inside an LED light? Hello?
Sir, query again, sir.
What is there inside an LED light, sir?
LED light.
Okay, what is there inside an AC? The latest AC. What is there inside? We call it as an inverter, right? Inverter ACs. Then LED lights have an LED drivers inside. Okay, the supply whatever I am giving it to this light, it passes through this driver electronics. Then it gives you the output. Output is the light output. Okay. When similarly the AC, if you are giving this, then it goes to an inverter. There is an electronics in between. Then output is an your tonnage output or the chillness, whatever is there. So now from generation point to the end use, we are introducing an electronics in between. At present, if you see, 30% of power is flowing through electronics. Balance all is direct. Okay, 30% of power is flowing through electronics. If I take this graph, okay, x-axis and y-axis. Hello. Okay. If I go for an x-axis, this is the percentage of power that is flowing through electronics. Okay. 30% of power is flowing through electronics. Balance 70% is directly it is flowing to the end use. Okay. If you are having a 30% of electronics, then the y-axis is an voltage distortion. You will have occasional problem in your voltage. Okay, you will have an occasional problem in your voltage. Now there was a study that has been done where they are saying that by 2030, 80% of power will flow through electronics. That means that whatever equipment you are buying or whatever equipment industries is designing or whatever equipment the power system is being designed, they will have one electronics in between. They will say that use this adapter or use this electronics in between because this is an efficient. If you are using this in between, it becomes an efficient system. 80% of power will flow through electronics. So if I go for an x-axis, 80% comes here. If I am taking 80%, then the voltage distortion problem is called as an acute problem. When you talk about the COVID, they have declared that virus as a pandemic virus. It's not an immediate declaration. They have waited for some time and then they have declared as a pandemic. Once it has been declared as a pandemic, that means that emergency has to be brought in. Similarly, our electrical system is moving towards this acute problem, which is equivalent to your pandemic. Okay, our electrical system is going to have this in another 5 years time. I'm saying 5 to 8 years time the problem is going to be, and you will not know what kind of problem you are going to have in front of you, because your electrical network is becoming more and more and more complex. So that's why I said whatever you are designing now cannot take care of the tomorrow's problem, but at least it can postpone the problem, or it can protect your system to some extent from the problem. Say, what are we going to address, how are we going to address this acute problem in your electrical network? Okay, then when you say about the industry 4.0, this is an industry 4.0. Now people say IoT industry 4.0, many things. So 1800, it all started in 1800s. In 1784 the industry 1.0 had started, where water and steam is used to create a mechanical movement. Okay, mechanical movement. Then second industry 2.0 had started, where in which they have started using an electricity. Okay, the electricity came in this period. Electricity is being used for labor and mass production. Then industry 3.0, where there was an automation that has played an important role. So automation in the sense, there was some PLCs and there was some logics being written, and some automation is being written. All this came in 2000s, 1969 to 2000s. This revolution had started. Now on fourth revolution it had started from 2000 onwards. Now we are talking about an IoT, so Internet of Technology. So when you talk about an Internet of Technology, that means that somebody is waiting outside to take the data, and they are analyzing the data and giving you the information in front of you. So till industry 3.0, the data was inside. So it's like the person who is analyzing the data, he is only going to use the data. Nobody from outside is analyzing the data. But in IoT, the data goes to a cloud where it is being accessed by 100 lakhs and lakhs and crores of people. And this data is being analyzed by someone. And if you are using an Axis Bank mobile app, or your ICICI mobile app, or your HDFC mobile app in your phone, your data is being sitting on a cloud, and they do some sort of analysis and keep in front of you, and they are saying that what is your usage of credit card, and how you are using the credit, or how much you are using it for an groceries, how much. So they are giving in front, they're doing all sort of analysis and giving in front of you. Okay, so this is where the IoT comes in. So when IoT comes in, then the problem happened. So people misused this data, and hacking of this data has happened. So then what happened is the artificial intelligence happened. Artificial intelligence came in, then block data, big data. So I have so much of data. There are two problems that will be in front of me. One is what I am going to do with this kind of data. So how I am going to do analysis of this data. So that's why the data analytics, big data, all this data, all this technology comes in. Then uh, if somebody hacks, or if I have, how do I optimize this data, how to optimally use this data, then artificial intelligence comes in. So many technologies that is coming in because of this IoT and the cloud technology. So what is happening? This I will not go. Okay. Now the main drivers for the digitization. Why I'm talking about this digitization is, when you are designing the future system, it should be digitized completely, and this data should go, and somebody should have a data remotely, because COVID has taught us a lot. So COVID has made, like, at least for the colleges, you are not going to the colleges, and you are doing all the things on a Google or Zoom meeting, Google Meet. But when what happens to the industry, if something is running on the industry, critical industry, somebody is there, I cannot travel there, so I need to take the data here. I need to see that data here in front of me, so that I can take a decision. Only limited people will be there. I can take a decision and tell them that you switch off this, or increase this production, or change this. I can do that. So The COVID has taught this. So all this happened because of the digitization. The data is being bought in front of me so that I can take a decision and tell them. So for this, if you talk about, there are key drivers for this. Key drivers is your mobility in the sense the data should be mobile, and it depends on your network speed. And there are a lot of technologies that is coming in, LoRaWAN, LPWAN technologies, then Sigfox. There are a lot of technologies that is coming in to pull the data and give the data to a centralized location. Then cloud, if I am getting all this data, somebody says that I don't want that data to be sitting here. If I'm going to US also, I need to access the data. So how do I get that? I will push the data to the cloud. So if you see, if you buy an iPhone now, they are giving an iCloud. So they are giving an iCloud of 100 GB as a part of your selling the mobile itself. So the cloud, the data goes to the cloud. So I store all my data on a Google Drive. So Amazon Web Services, there are a lot of data centers that is coming up. Lot of data centers. I've seen in last 2 years, 2 years time, so much of data centers have come up in Chennai. So much of data center have come up in Mumbai and Bangalore. Okay, so Amazon Web Services provide you full IT infrastructures. So there are a lot of STT, NTT, Google data, Microsoft data, data centers. Many data centers are coming in. So now, and then next thing is, whenever you design a system, make a system to speak. Okay, earlier designing the system efficiently is will make the system resilient, but now make the system to speak so that the data comes out. So what you need to do is, you need to become sensors. You need to put so much of sensors, and then wiring will be a problem. So you need to put a sensors which is a wireless sensors, and it should be smaller, and it should be economical, and it should get connected to the cloud. All this should be designed. Okay, there are lots of products that is coming up to put it in an electrical system or power system to make your system talk. Then you need to have some sort of system for analytics, getting the data, and I'm getting the data from these sensors. I'm putting these data on a cloud, and if I don't do an analysis of the data, it is of no use having all this. So analytical plays an important role, like your artificial intelligence, machine learning, blockchain. All this makes sense of the data, big data that you have in front of you. Then when so much of data, then cybersecurity. So these all the key drivers should be considered when you're doing any electrical system design, or when you're making any power systems. This is all going to be the future. So that's why I'm saying this has to be considered while designing a system for meeting your future needs, as well as to make your system more resilient. I'm not going to this. Okay. 3 years of challenges that I thought. One is the COVID-19 and energy transition and climatic impacts. So for COVID-19 has helped us to go for a next level. When this COVID has happened, people, they cannot commute to work on that. So then after COVID, they made the complete digitization, and they said, if I am having a next COVID, sitting in a place, I can work. So earlier we don't have this kind of Google Meets. We never had this kind of Google Meets, okay, or the Zoom meetings. But now every people, even the small kid, also know Zoom meeting, and all the classes is being done on Zoom meeting. If there is a rain, they're giving a leave to schools and then colleges, and they are putting it on a Zoom meeting. So it's not that I need to go to the school only to. So COVID-19 has helped us to go for an 100% digitization. And energy transition is like electrification, more and more electrification, renewable electrification helped us for an energy transition. For climatic impacts, the sustainability is the key way, where people are now talking on an COP29, where they are trying to reduce down the carbon dioxide emissions. Then digital adaptations. Okay, this I will not go. This will not go. Okay, this is the difference which we will telling about. Carbon neutral. So this is removing an equal amount of carbon dioxide as the company creates or your system creates. So carbon neutrality specifically focuses on neutralizing the carbon dioxide. Whatever I'm giving it, I'm neutralizing here. Okay, this is pertaining only to carbon dioxide. That's why it's called as a carbon neutral. If I am giving and then taking it back 100%, then it's a zero. It's a neutral. Then it is applied to company products or services level. Okay. Now net zero is, it is tracking all the greenhouse gases. Carbon dioxide is one of the greenhouse gases, but here it is all the greenhouse gases which means it's not only restricted to carbon dioxide. So what are the other gases? Methane, nitrous oxide, fluorinated gases emission, all the other things. Okay. So this is applicable to global nation or the company level. When you're talking about your grid or power system design, it should also to be net zero or carbon neutral. It should also meet the net zero, or it should not give more carbon dioxide emission. Okay, this is the definition which you need to mug up. Jaiswa sir, you have given some points in this. It is meeting the needs of the present. Okay, this white you have told clearly, but this has to also to be added up without compromising the ability of the future generations to meet their own needs on their own. This is the definition. And the difference between weather and climate. So we always say that weather is fine or climate is fine, but there is a difference between this. Weather is on short term, it is on day to day basis. When I'm saying weather, the weather is nice, that means that yesterday it was too hot, today it is cold. Okay, weather is a short term, it is on day to day basis, but climate is a long term. So if I talk about the Coimbatore, I will ask what is the climate of Coimbatore. So that means that on an average you will feel like chill. So you will say that Coimbatore is like this. If I am talking about a climate of Chennai, I will say Chennai is hot. Okay, that doesn't mean that Chennai is having an cold. During January, February, we will also have an cold temperature. But on an average, I'm talking about a long term patterns and average of weathers gives you the climate. Okay, that's why people are now talking on a climatic change. They're not talking about weather change. They're talking about a climatic change. But soon the weather also will be a concern. Every day it will get changed. Your Coimbatore is going to get changed. So whatever you said the chill, today it will be chill, tomorrow it will be too hot. You will not even guess what is going to happen tomorrow. Okay. So the weather is going to have impact when the climate. So what is the thing is great climate, atmosphere, hydrosphere, cryosphere, and biosphere. Sun powers the earth climate, the carbon cycle, and you should also have a carbon sink and greenhouse effect. So why we are talking about a greenhouse effect is the carbon dioxide, whatever we are emitting into the atmosphere, is going to be there in the atmosphere for 100 years. It is not going to die. When I'm giving out the methane, it is going to be the atmosphere for 10 years. When I'm putting in water vapor, it is going to be there for 1 year. Say the plastics. When you are talking about the plastics, they say recyclable plastics. What does it mean? If I'm using a non-recyclable plastic and put it on the ground, it takes thousands of years to get decomposed. It will not decompose also after 1,000 years also. But when you are putting this recyclable plastics, at least it can decompose 50 percentage. Or if you're using a paper and throwing it, it gets decomposed. So the amount of time it takes to decompose is the one. Similarly, this is under the ground we are talking about. On the atmosphere, which is above the ground, the carbon dioxide is going to be there for 100 years, which is going to create a problem. Okay, or the carbon dioxide whatever is there in the atmosphere, try to take it out. How do we take it out? We cannot inhale the oxygen, we cannot inhale the carbon dioxide, we will die. So somebody who inhales the carbon dioxide, which is a plant, grow more plant which inhales more carbon dioxide. So that means you are creating a sink here itself. Okay, I'm not going into this. Okay, this is an India's commitment which you need to know, because we are all in Indians and we need to know what is the India have committed. So when you are designing a system, you should also keep this in mind in such a way that your system meets the India commitment. Okay, what is that India commitment? They are saying that 50% gigawatt. It's a non-fossil fuel based. Okay, whatever is there, 50% people are saying that we will meet the energy demands by a non-fossil fuel based. Okay, then 45 percentage of reduction in carbon intensity. That means that people are saying that how much of carbon dioxide we have left it out, we will reduce down 45 percentage of that. 50 percentage of energy requirement should be met by renewable energy, be it a solar or hybrid, or your windmill, or your geothermal or biomass, whatever is there you can use a renewable energy. Then 1 billion tons of carbon dioxide emission reduction and net zero by 2017. So this is the five panchamrita being taken by India as a commitment. Okay, and this has been committed in COP27. Okay, COP26, and there is a COP29 that is going to happen now, and people are reviewing that every year. whatever you have committed, you are meeting it or not. So they are reviewing India. Okay, when they are reviewing in India, so we should design the system, or we should use a product in such a way that this meets that review. Okay, the fastest path to the net zero. So what is that fastest path to the net zero is electricity 4.0, which should be considered. Then, sir, Jaiswa sir, how much time I can take? I don't know how much time is left for me. Hello, hello, Jaiswa sir.
Yes, sir.
Thanks, sir. I was just thinking of whether my network got disconnected. How
No
much time
issue.
I
No,
can take?
no,
How
sir.
much time? How much time I can take?
You can continue, sir. No issues.
Okay. So, if you talk about an India growth trajectory, there is a new energy landscape. This is a new word which you will learn. Go and search in the Google. Okay, what is this new energy landscape that's coming up? Okay, the new energy landscape. It talks about like India is growing bigger way. India is growing bigger way, and we are marching towards what you call the uh, growing. We are India is a growing country, we say. Instead I'm saying we will become like an US completely. Economics India is the fourth. India has the fourth largest railway network, and 220 plus airports is being planned for 2030. India goods export will reach 1 trillion US dollars. Then India is aimed to reach 500 gigawatts. So this is not a small. Even the global countries cannot reach this. Okay, but we are committing this, and then we are reaching this in a short term. Okay, when you're talking about a new energy landscape, so when I have so much of growth in front of us, there is a new energy landscape that is coming up. What is they are saying is two times of energy consumption and 6 times of electricity demand by 2047, and increased in safety of electricity. These all the things that you need to keep in mind when you're designing a new energy landscape to meet these needs. And it should be more and more efficient. Your system should be more and more efficient. Your system should be more and more safety. Then you demand for a high power availability. So people are asking for a high power. Say when I saying 220 plus airports by 2030, when you're inside an airport, and if the power fails, what will happen? What will happen? You'll shout like anything. But in house, if it fails, it doesn't matter. You will wait for some time, or your inverter comes in. But in airports or the critical hospitals, if the power fails, then there is a big task, because I'm going for so much of growth, and I have the problem in front of you. Okay, there is a demand for a high power availability. That means 24 bar 7. There is a high demand for this. So for all these things, what we should do, if you want to go for a high power availability, then you need to use a system, you need to design a system which is certified to some international standards, then which should be safe and compliant to electrical networks. There are some IS standards, there are some IEC standards. It should meet all these things. When you are saying, when you are buying a AC, we say that the AC is an efficient AC when it is a 5 star. That means that it is meeting some BIS standard. When I'm meeting the BIS standard, it is more efficient. Similarly, it should be safe and compliant to electrical networks. Okay. Then on sustainability, so India will become carbon neutral by 2070. So implementation of RRR. This is not the movie RRR. So this implementation has to be put in like reduce, reuse, and recycle. When you are designing any electrical system, it should reduce down your energy consumption, it should be reusable, then it should be recyclable. The product whatever you are designing it, it should be recyclable. This should be the three things that you should keep in mind when you are designing any electrical system. There is a high energy efficiency opportunity in India, because why I'm talking about an energy efficiency is the system should be resilient. If it is only efficient, then only it can be resilient. So there is a high energy efficiency opportunity in India. If you are talking about a best in class energy, so I'm talking about, there will be some buildings, there will be some hotels, there will be some industries, there will be some hospitals. This is what we know. Okay, when I'm talking about an offices, Best in class energy consumption by officers is rupees 3.25 per square feet per month. This is the amount that they are spending towards an electricity. Okay, but in India we have 14 rupees per square feet per month. This is the energy cost that we are paying in. Best in class is 3.25 and we are paying 14 rupees. How much loss that we are making it. Okay, there is a huge efficiency gap. When you're talking about an industry, when I'm talking about an iron and steel industry, they produce an iron or steel in tonnage. Okay, 1 ton they make 1,000 tons or 2,000 tons per day. In globally, if you see, for 1 unit of tonnage of electricity, the for one tonnage of iron and steel production, people are paying 6,900 rupees for 1 ton of production of iron and steel. But in India, the same iron and steel, we are paying 9,700 rupees per tonnage production of iron and steel. So we have a 30% gap. Okay, this is the opportunity in front of us to make this opportunity to the best. It is very difficult to make this opportunity to the best. Say if you are going for a running race and you are running an 100-meter race in 15 seconds, the best is 9 seconds. You cannot go to 9 seconds. If you're going to 9 seconds, you will be a world champion. You cannot go to 9 seconds. At least march towards your 9 seconds. So from 15 second, you keep on changing yourself, or you're designing, or you're making yourself. Then from 15 you can go to 14, but it takes a lot of time. From 15 you can go to 13. Slowly it takes a lot of time to reach that 9. So there is a opportunity in front of us. Make use of this opportunity to design a system. So this is the future industries is going to be marching from this to this. So your system should be in such a way that you should reduce down, or you should measure this and say them, this is the worst case and I am improving. So that means that when I am improving something, then I am going, say there is a word saying, just I just saw in a hotel where they say, making a mistake is the first step of success. Okay, this is the word which everybody will tell to us. Everybody gives advice. They say, make a mistake, that is the first step of your success. But they have written it is not the right word. Correction of the mistake is the first step of your success. Correction of the mistake, once when you start correcting the mistake, then you are marching towards the success. So this is the worst case. When you are starting marching towards your correction, making this to this, then your system will be more resilient, your system will be more efficient. So this is the future demand. So now more and more greener buildings are coming up, more and more green industries are coming up. People are now talking on an ISO 50001 in industries. When you are talking about future industries, will be all industries will be ISO 50001. When you're talking about a future industry, it is not only that industry, many buildings are also coming up now. Okay, future buildings and future industries, keep this two: designing future industries and future buildings. When you are designing a future buildings, all the buildings should be green building. Now if you see, only 5 to 10 percentage of the buildings is a greener building, but there is a mandate that is going to come up. Any building that is going to be built should be green building. It should be certified by IGBC. IGBC is like a Indian Green Building Certification, IGBC. So why green building matters is, this is going to reduce down 30 to 50 percentage of reduction in energy consumption than the normal building. Okay, then it uses up to 40 percentage of reduction in freshwater demand. So there are three things in front of us, three basic needs. What are the three basic needs? Air, water, and food. So I'm reducing down the reduction of 40 percentage. Okay, when I'm using a green building, 40 to 65 percentage of reduction in water consumption when the building is being made green, and 30 to 40 percentage reduction in operational cost of a building. Now when you are buying a, Mercedes Benz car, what people normally say is maintaining that is a problem. நம்ம தமிழ்ல சொல்ற மாதிரி இதுதான், யானை வாங்குறது பெரிய விஷயம் கிடையாது, பட் யானையை மேய்க்கிறது தான் இட்ஸ் கோயிங் டு பி பிக் டாஸ்க். Similarly, the operational cost when you are designing any industry, it should be in such a way that the operation cost of the industry is getting reduced down. Operation cost is day-to-day cost that they are spending to make the system running. Okay. Now, if it's a green building, it is going to reduce 30 to 40 percentage of operating cost. Okay. Now this is one. And when you're going for a future landscape, right, to India to be one of the global leader in green environment, green building environment, India's green building footprint is going to be 13 billion square feet. India green building market is $300 billion. That's big things that we have in front of. So when you are designing any industries, it should be ISO 50001 certified. If I'm saying ISO 50001 certified, I don't know whether your college is ISO 9001 certified. Some colleges they also put like our college is an ISO 9001 certified, which means that if the college is an ISO 9001 certified, that means they follow some systems and process. Similarly, when I'm talking about an ISO 45001, that means that it is safe. Okay, when you're talking about an industry, they say that it should be ISO 45001. That means that it is concerning that occupational safety health. Okay, if you're taking care of that, then the certification will be given to you, ISO 45001. Similarly, on energy, they say ISO 50001. You can note it down, this 50001. You can start reading this 50001, because future everybody will talk, every industries will talk about ISO 50001 industries. Okay, just talk, think about this ISO 50001, which talks about an energy management system. Okay, future industries will be ISO 50001 certified. Future buildings will be green building. So this two is going to be in front of you. Whatever design you are going to do, make in such a way that this two is being met. Okay, now I'm not going into this. Okay, this I just want to explain you energy efficiency versus energy conservation. What is energy efficiency is, this involves use of a technology. Say the LED lights is an energy efficient product, which means that it involves the use of technology to reduce down the energy consumption. But what is conservation? Conservation is belonging to the human mind. When you are going out, it's a human behavior. When you are going out of your room or out of your place, you need to switch off your light, you need to switch off your fan. This is what the conservation is. So when you are going out, if you are switching off, you are conserving the energy. But now people are not doing that. So for this also the technology comes in, like there is an occupational sensors that is coming in, and automatic sensors. When you are going out, if people are not there, it will automatically switch off the occupational sensors. So energy conservation also is being now being technology driven. Okay, efficiency, it focuses on an equipment or machinery, but whereas conservation, it focuses on behavior of a people. Example is LED lightings. Here the example is day lighting. So when you are designing any system or any electrical system or any, make in such a way that you are using a daylight rather than using an electrical energy. So that means that you are conserving the energy. So for all these things, you need to understand three pillars, which is a measure, understand, and act. So that means that you should measure how much of, like when you are going to a shop and you don't have a credit card, you don't have your mobile. Okay, Google Pay, no Google Pay, no credit card, and no debit card, and you have only money with you. What you will go before going into the shop? You will think like, I need to buy this equipments. Before that, you will take out the money and then you will count the money and see how much money you will have. So you will go inside and then you will see what all the things that you want to buy. Then you will match this, the money whatever you have, you will match this, how much I can buy. So for this, similar to that, when you are going for this, you should also measure. Then only you can manage that, how you are going to manage. So measure leads to a management. So gather accurate power and energy data from key distribution points. Then you should also monitor the quality of the power, how the quality of the power is coming in. Because designing a system efficiently is fine, but if the input to the system is not good quality, then ultimately it's a loss for you. Say when I have a, what you call the water filter, when I may have an good efficient high quality electrical products appliances in my factory, but the input to this is not good, the voltage input from an electricity board is not good, then all the equipment will fail. Efficiency of the equipment doesn't play an important role. Equipment will fail, equipment will trip. So you should understand the quality of this. Then you need to act based on the data. So there is an efficiency versus sufficiency. Okay, we always know on an efficiency and sufficiency. Now people will talk on an sufficiency. Okay, what is energy sufficiency? It's not same as an efficiency. Energy efficiency focuses on the technology. It's purely on the technology. Design a system in such a way that this uses a new technology to make your system efficient. As I told you, the law of energy is conversion from one form to other form. When it is converting from one form to other form, how you are reducing down the losses plays an efficiency. When I am giving an electricity to an incandescent light, or when I am giving electricity to an normal tube lights, it will give an output of lumens. Okay, but the efficiency is very less. So now what I am putting is, I am putting an electrical lights. I am taking this bulb and then I am putting an LED bulb, which also gives the same lumens, but with 1/10 of the energy consumption of the earlier bulb. So the technology plays an important role for energy efficiency. But for energy sufficiency, you should make a system in such a way that it is helping to reduce down your energy consumption, then your carbon emission. Okay, so just for an example, so here if you say energy sufficiency is, you can say, suppose you are inside a room and you are feeling too cold, you can put a heater. Okay, you can put a heater to make the room cold. Now instead of using the heater, what I'm doing is, I'm getting the same feel of that warm or hotness by putting a warm clothes. If you're wearing a warm clothes and turning down the heater, it isn't sufficiency. That means that you are meeting your demand, thereby not using the energy. Say we know about this kilowatt, watt, kilowatt, megawatt. Go to Google and search for a topic called negawatt, NEGAWATT. In future, everything will be called in negawatt. That means that for running the same thing, how much of energy I have not used. Megawatt, what you are saying is the energy that I have, the power that I have used. Negawatt is that I am not used to meet that demand. Okay, both are different. Negawatt and megawatt is both are different. So future will be on that. So how to make this energy sufficiency is, avoid an energy waste. Okay, reduce number of devices, extend the way of thinking it in all the way. So reducing our environment impact together with green premium. So this plays an important role when you are designing any system. Design a system with green premium products. So what is that green premium products is? Like one example is the cloth bag what you use and green premium. Okay, but the plastics what you use is not a green premium. Similarly, any product which doesn't do harm to your three basic needs. What are the three basic needs? Your air, water, and land. If it is not polluting these three, then it will pollute, but it is not polluting in a bigger way, then I can call that product as a green premium product. So when you are designing any system, search for some product to put in your system which is green premium. Okay, so with this I just close my presentation. Any doubts or any clarifications? Hello.
Thank you so much, sir, for your wonderful presentation.
Sir, the last one which I want to tell to all the people.
Okay, sir.
So this is the last slide. Okay.
Okay.
There is a Vivekananda quote, right? Arise, awake, and do not stop until the goal is reached. The Vivekananda in a old generation, he could have told this, but the new generation Vivekananda, he will say, arise, awake, and stop the carbon dioxide emission and make the world more sustainable and livable. So keep this in mind when you are designing any system. It should be reducing down your carbon dioxide emission and to make this world sustainable and more efficient. Okay, that's it.
Thank you, sir, for your wonderful presentation. And dear participants, it's the time for question and query session. If you have any queries, you can turn on your mic or else post the queries across the chat box. I repeat, if you have any queries, you can turn on your mic or else post the questions across the chat box.
So this is the worst students I have seen, sir. Nobody is asking me the question.
It's not like that, sir.
Nobody is answering. Nobody is asking the question also. And you can circulate my number to all the staff, sir. If they want to talk to me on
Yeah, sure, sir.
something, they
We'll be
can.
sharing all your all the PPTs being shared by the presentees, and the things will be shared as a Google Drive as
Okay, sir.
day basis.
Sure. Any feedbacks or any recommendations?
We'll be sharing the feedbacks to the participants, sir. After collecting the responses from the participants, the feedback will also be shared to you, sir.
Do let me know, sir, because this 1.5 hours, whatever you gave me, is not sufficient. So whatever I can able to tell in that 1.5 hours, I've just collated because that's an
Yeah,
urgent need of now. But I require another 2 hours or 3 hours also
yes,
to
sir. The
go
things
in depth.
which you have shared will be has to be covered a minimum of 3 hours. You have
It's
given the
I
glimpse on all the topics, how the resilience is being happening in industries, and how the power system has to be modified across in future aspects. These are all the things which have to be detailed in a brief.
do
And
let me know, sir, if you have any face-to-face session. Do let me know.
sure, sir. We'll let you know shortly. In upcoming months, we have to go. We have to go for programming for students also. We are planning for students also, students events. At the
Sure,
time, I will be contacting you, sir.
sure. Do let me know, sir.
Yes.
Thank you all. Thank you for giving me this opportunity to tell you, because you are the brand ambassadors of taking this to the students. Because whatever I feel is when I tell to one, it gets multiplied by three. In one of the movies I have saw, it's a Telugu movie. It's a fantastic thing. He will say that when he does a favor to someone, they will ask you what I should favor you because you have helped me a lot. He will say that do this to only three people. He will say, whatever I did to you, do this to three people. He keeps on telling to all the people. Okay, then one of his friend will ask, why you are saying three people, it doesn't make a big impact. Then he will say, come sit down. You know the Amway, right? You're using any Amway product, sir?
No, sir. We are not using.
Okay.
No, but
Now,
I'm not using.
no, don't. I'm saying it's up to you to use your product. I'm just saying how they have marketed that multi-level marketing. Okay. What they do is they create a tree, bigger tree. So 1 to 3, 3 to 9, 9 to 27. It keeps on increasing. So he will put that and then he will say that if I'm telling to three people, these three people, they will say that do it to other three people. Okay, 1 to 3, then 3 to 9, it gets increased. All the three people will. So when he will put the tree and they will show, see if this goes, it keeps going. Okay, the easiest way for me to reach on the sustainability to different people is to the faculties, because you are creating the people, you are creating a society. It's not a people. I will not say people because you are creating a society, you are creating a planet. so much of respect for the staff. So when I'm giving something, give it in a double way to the students, because I may be giving it to 90 people and you 90 people will be giving to 9,000 people. Next 10 years you may be giving it to 9,000, 90,000 people. It keeps going. So that's why I'm saying the faculties is more important to understand on this problems that what we are going to face in front of us, because you are not going to design any whatever knowledge you are going to get, give it to the people. When they get on campus interview or going to an industry, they are going to design the system. They will think this in mind, like my staffs have thought this, I need to design my system in this way. You are not going to give a complete design to them. At least tell them that what need to be done, and they will do it on their own. But so the sustainability keeps spreading like anything to the people. Thanks.
Thank you so much for your wonderful presentation, sir. And your topic will be a new awakening for all the participants to carry out their future aspects in power industries. And now I call upon Deepika to deliver the vote of thanks to the resource person. Is Deepika is audible to you?
Yes, sir. As we come to the close of today's enlightening session, it is my privilege to deliver the vote of thanks. On behalf of everyone present here, I extend my heartfelt gratitude to our esteemed resource person, Mr. R. Suresh Kumar, for sharing his profound knowledge and expertise with us. Sir, your insight into energy management systems, power quality, and harmonic solutions have not only educated us but also inspired us to explore these areas with greater curiosity. A special thanks to our institution for making this session possible. I also thank the audience for their active participation and enthusiasm. Let us carry forward the knowledge we had gained today and apply it effectively in our respective domains. Thank you all for being a part of this event, and I wish you a wonderful day ahead. Thank you.
No, the program is not ended. We are having another session, which is the last session of today's program. It's not only for today, it's total adult program.
Hello, sir. Good evening, sir.
Yeah, good evening.
Feedback link is not working, sir.
Yes,
Okay,
that's
sir.
that's what I want to tell you, sir. Feedback is
Okay,
not
okay.
working.
Thanks for notifying, sir. Thanks for notifying.
Okay, okay.
We'll check it again.
Thank you, sir. All the
Sir,
best.
thank you so much, sir. Thank you. Thank you
May
for
God
sharing
bless
your
you.
valuable time in spite of your busy schedule.
May God bless you all, and then a happy weekend. Enjoy the day. Keep spreading.
Thank you so much, sir, and wish you the same again. Thanks, sir. And Gomati Shankar, sir.
Yes, sir. Good evening, sir.
Good evening, sir.
Is my voice audible?
Yes, sir. Your voice is audible.
Hello, sir.
Sir?
So is my screen visible?
Yes, sir. It's visible, sir. And Deepika?
Sir?
Okay. Let's continue for the last session. Sir, shall we start, sir? Gomati Shankar, sir?
Yes, sir. Yes, sir. You can proceed.
Okay, sir. Thank you so much, sir.
Good evening, everyone. I am Libika from Electrical and Electronic Engineering Department of Sri Krishna College of Technology. I welcome you all to the third session of the day 6 of the Faculty Development Program. It's my great pleasure to extend a warm welcome to all of you present here today for this insightful session. We are privileged to have amongst us a seasoned professional and a visionary leader, Mr. Gomati Shankar, who has made remarkable contributions in the field of electrical engineering, operations, and automation. I welcome all the faculty members and participants to what promises to be a
thought-provoking and inspiring interaction. It is my privilege to introduce our esteemed chief guest for today, Mr. Gomadi Shankar, the head of electrical operations engineering at Siemens Gamesa. With over 17 years of dynamic experience in electrical system design, operations, and project management, Mr. Gomadi Shankar has consistently demonstrated excellence in leadership and technical expertise. At Siemens Gamesa, he has successfully led teams and spearheaded projects in renewable energy, ensuring technical accuracy, operational efficiency, and adherence to safety standards. Prior to this, he contributed immensely to FL Smith in roles ranging from lead electrical engineering to deputy chief designer. His extensive skill set spans across electrical panel design, PLC, SCADA programming, automation, power systems, and supplier quality management. Mr. Gomadi Shankar holds a Bachelor of Engineering degree in Instrumentation and Control from Anna University. With his vast experience in leading cross-functional teams and mentoring professionals, he stands as a source of inspiration and knowledge for all of us. We are truly fortunate to have him here today to share his insights. Over to you, sir.
Thank you, Ma. Thanks for giving this brief introduction about me. So, good evening, one and all present here. So, today I am going to discuss about the cybersecurity challenges in smart grid systems. Is my voice audible?
Yes, sir, it's audible, sir.
Oh, okay. Sir, I am in full screen mode. If my voice or my presentation is not moving, kindly notify me. I will reconnect again. Okay.
Sure, sir, sure.
Thank you very much, sir. So before entering into this smart grid system, so nowadays the nation across the world facing the challenges of increasing power production while reducing the carbon footprint. So they need to minimize the power loss and downtime, harness alternative power source, and so on. So with this we have a numerous challenges facing them. The one of the solution for the power solution for this power grid is the smart grid. Okay, so while speaking about this smart grid, it brings the improvement in cost and performance. The security of the power grid becomes more complex and risky. We're calling for comprehensive and integrated solution. So already we know the key component of the smart grid solar system is called as generation, then transmission, then distribution, and the consumer interfaces. So this is the last in. So like this only we are going to distribute the power from our generation to the customer interfaces. So the significance, the benefit of the smart grid is first one is called efficiency, then sustainability and real-time monitoring. So with these major three benefits, we are going for the smart grid system. So with this, so we already know what is smart grid. So because of the digital upgrade to the existing electrical grid technology that has been quite the same for more over 100 years. So integrating of electrical infrastructure with the information infrastructure, we are moving into the smart grid system. So the identified as a bigger opportunity that they have an internal in internet itself. Without the internet, we cannot exchange the information from the one place to another place. So various points of power generation communicates with each other and use the shared information to make the intelligent decisions. So with this terms, the smart grid means it is the combination of the energy power grid as well as the communication plus intelligence plus automation. So all these components coming together to form a smart grid system. So without this, like the energy, like what I am saying, existing the existing power grid, communication, intelligence, and automation. Okay. So with these all these components, it combined together, it form a smart grid system. Okay. So while speaking about the power grid automation, so we need some set of parameters, we need some set of components. So without that, we cannot enter into the power grid automation. Okay, so like this, so from the SCADA system to like the distribution of power. Okay, so first we have to planning, then asset management, then engineering, then accounting. So all these are comes under the corporate level. So basically the automation, power automation is categorized into three categories. One is called corporate, another one is called control center, then third one is called power grid automation system. So all these substation, then control center, then corporate. These three comes that form a power grid automation system. If you're speaking about the first component, that is called corporate, it comes under the planning, then asset management, then engineering and accounting. So all these parameters comes under the component of corporate. Then if you go talk about the control center, it is like a SCADA system, like so user interface, then dashboards, so controlling of panels, controlling of power generation, okay, so transmission, distribution, operating, training, so communication front end, then ICCP servers, so information model manager. So all those parameters are comes under the control center. So this is the second parameter, second key component. Then if you go for substation, there is RTU, then PLC unit, then inputs, then log servers, then HMI. So what are the components, what are the hardware components involved in the in the power station? This all comes under the substation, like meters, and then wired IO inputs, then wired outputs, then communication switches, communication process, so field device. So all those components are comes under the substations. Okay, so with these three major component, we can go for the automation of power grid. Okay, without these three, we cannot go for the automation of the power. Okay, so with this significance, there is benefit of smart grids: efficiency, sustainability, and real-time monitoring. So with these three significance, we are entering into the smart grid system. Okay, so next, why it is important for cybersecurity in the smart grid system? So I am going to discuss some of the use cases and case studies related to the cybersecurity in our smart grid system, as well as some other applications also in the coming slides. So what is the need of cybersecurity in smart grid? So traditionally, power grid automation system have been physically isolated from the corporate network. Already I said there are three components involved. One is called corporate, another one is called control system, third one is called substation. Okay, with this three combination, we are going for the automation of power. So if you go for automation of power, definitely we need a cybersecurity component. Without the cybersecurity component, we cannot go for the automation. Okay, why? Because already I said, so we have a three basic component. One is called communication, intelligence, automation, then existing power grid. These all combine together to form a smart grid, right? So with that, we definitely we need a cyber security in the smart grid system. Okay, so this has been challenging peripherals due to the cost effectiveness of utilization of public networks. Okay, so using public network considerably increasing the vulnerability of power grid to cyber attack by increasing the exposure surface of this network. So with this only we are going for the fully focusing on cyber security in the smart grid system. That's why today's topic is called challenging in cyber security in the smart grid. Why it matters depends on the interconnected system and potential vulnerability. So vulnerability is nothing but the weakness or flaw in the system. Definitely, if you go for automation, then that automation system is connected to the internet. Definitely, it may be a possible of vulnerability in the particular system. It may be a system, or it may be a device, or it may be a control environment. Everything it will be connected to internet means it is definitely vulnerable. Okay, so vulnerable in the sense it is flaw or weakness in the system. So impact of cyber threat, it definitely, if the cyber attack or if any cyber threats are happening in the system, definitely it will cause some impact. That impact may be in the case of the smart grid system, one is service disturbance, then data breaches, then financial loss. So these are all the three main components involved in the smart grid system. Okay, if any attack is happen on the real-time world in the control environment on the automation of power grid, definitely the service distribution will be occur, then the complete data breaches will occur, then the financial loss. So to overcome these three, we have a complete framework of cyber security to protect our data in the smart grid system. This is the second thing that is called impact of cyber threats. Then third one is called regulatory perspective. So already this previous session what the Suresh sir told, right? So we have a separate standard for each and every standards for protecting the data. So for that, so for protecting the information, we have a information security system in ISO 27001. So this is completely for protecting of information security. Okay, so now the industry will follow the ISO 27001 2022. So that is the standard. Now still now we are following. So not only in the smart grid, if you go for like banking application, or if any other big organizations, definitely they have to follow this ISO 20001, because 3 years back the RBI government, RBI, this Reserve Bank of India, is giving one circular to all the government, all the banks. Definitely, all the banks should have an ISO 27001 to 2022 has an compliance to protect the information on the customer data, to ensure that we need to go for this ISO compliance. Okay. So next one is to need for cybersecurity for a smart grid. So already I said that we have to we have a 3 benefit. With that benefit, we are going for the cybersecurity of the smart grid. One is called the ability to deliver the electric power to customer reliability, then accurate billing. Then third one is called to prevent the system from the different attacks or different vulnerabilities. Okay. So with this, we have a 3 different principle on the cyber security. So without these 3 principles, cyber security will not be involved in any other application. It may be a banking sector, it may be organization, or it may be a power, or it may be anything. Okay. So definitely they has to follow these trials. This is called trial. This is called CIA trial. So first one is called confidentiality. Second one is called integrity. Third one is called availability. Okay. So with this 3 CIA trial, definitely we have to put out the cybersecurity information from the various attacks or various vulnerabilities. First one is called vulnerability. So with this 3 CIA trial, I will give you some. Okay, with an explanation, with an example. First one is called confidentiality. If suppose, for example, we have a mobile device. So we are sending some message from one device to another device. Like if you take in WhatsApp, so I am using same WhatsApp. You are also using WhatsApp in the another end. Okay. If I am sending one hi message from my WhatsApp to your WhatsApp, you have to ensure that that hi message is sent from the authorized user from the receiver end. Okay, that is called the confidentiality. We have to ensure the confidentiality of the data, whether the data is coming from the authorized user or not. That is called confidentiality. Second one is called integrity. So integrity is nothing but, if suppose for example I am a sender, you are all the receiver. Okay, so I am conveying some information through our Google, like through our Zoom meet, right? So with this conveying information will be reaching out to the customer without any alter. That is called integrity. Okay, whether my conveyed message is received from your receiver end without any altered data. That is called integrity. Okay. Third one is called availability. So whoever the customer is an authorized customer, those authorized customer has to receive the data from the particular server. Okay. If you go for complete automation, definitely the server will be involved on the particular end. Okay. If the server has to respond based on the customer request, if the customer is not registered on the particular server, definitely the server will not hit the respond to the particular customer, right? That is called availability. So whomever the customer has a registered customer on the server, those customer only they has to receive the data from the server. That is called availability. So with this 3 CAA trial, we need to protect the data on the smart grid application, as well as different application throughout what we have discussed earlier. Right. So this is the major security objective in the smart grid as well as other application also. That is called CIA triad. So with this 3 principle, with other than this 3, we have another 2. One is called accountability, another one is called authenticity. So this 2 is not applicable to all the application. So based on the application demand, these two principles will involve on the CIA, but the basic principle of the cybersecurity is 3. That is called CIA triad. So now I am going to discuss the 5 real-time challenges facing in the smart grid system. Okay, first challenge is called vulnerability in common communication network. First one. Second one is called lack of standardized security protocol. Third one is called insider threat. Fourth one is called managing IoT devices and legacy system. Then fifth one is called real-time attack detection and mitigation. So these are all the 5 major challenges facing in the smart grid application. I am going to discuss only on the smart grid application, not other than that. Okay, so first challenge is vulnerability in communication network. So already we know, so wherever the communication is involved, definitely the 7 layers will be involved directly or indirectly in the real time. Okay, so 7 layers means there is called OSI layer and ISO layer. There is called Open System Interconnected, or as well as organization standard for ISO. That is called International Standard for Organization. This is called OSI. ISO layer will be involved for the transferring of data from the lower level to upper level layer, then upper level to lower level layer. Okay, already I hope you all know the 7 layers of communication. So starting from the physical layer at the lower level to the application layer at the higher level. Okay, so why I am going to discuss this challenges and first challenge. Already I said smart grid involve the existing power grid, then information, then these 3 parameters. What is that 3 parameter? Communication, intelligence, and automation. Other than that, we have an existing power grid. So all these 4 components comes to form a smart grid, right? So definitely wherever the communication is occur on the automation power grid, definitely these 7 layers will be involved directly or indirectly. Okay, so definitely we must know how these 7 layers will operate on the communication network. Okay, from the top down approach as well as bottom up approach, from the starting from the physical layer to the application layer. Okay, so the vulnerability in the communication. So each and every layer has operated in the separate protocol. Okay, so all those protocols are linked to the common ports. Okay, so I don't know whether you all know or not. So if in our computer, in our system, in wherever the system will be involved, there we have a 65,535 ports are there. 65,535 ports are there. Out of these ports, we are using only 10% of ports are only we are regularly using for the communication between the one end to another end. Okay. Remaining 90% of ports are open ports. So what the open ports does, definitely if the open ports is found out from the attacker, there may be a possible to enter through the open ports. Why? Because these open ports are not used by any other communication. So the ports, what is ports means, if suppose for example I am going to use the printer, I'm going to take a print. Okay, so if the print is involved, if the print is involved, definitely we have to take a USB cable from the printer, we have to connect it to the system, right? So if we are giving the print from our system through the port only, that USB will communicate to the printer system, right? So if the port will not be involved, means definitely the communication will not be happen from the one end to another end. Okay, that's why I am given as a first challenge as vulnerabilities in the communication network. Okay, so out of the 65,535 ports, 10% of ports are regularly using ports. Remaining 90% of ports are not using. So all those open ports, the attacker may into the system, they may hack all our data on the it may be system. Okay, if the common system is no problem. If take an example of a complete automation of power grid, there may be a control system. So through the control system only, we are going to control all the hardware as well as software through the one control room, right? So if any attack is happening through the communication channel, definitely the complete system will be a collapse system, right? So that is why I am giving as a first challenge as vulnerability in communication network, that will be involved from the 7 layer. So the bottom from the physical layer to top from the application layer, like a physical layer, data link layer, network layer, then transport layer, then session, presentation, and application layer. Okay. So like this only, we are going to communicate the data through the internet. Okay. Wherever the internet is involved, definitely this 7 layers will be involved to carry the data from the one end to another end. That is the first challenge. So second challenge is lack of standardized security protocol. Okay, so we already, I hope we all know, so the difference between the authorization and the authentication. So definitely we need to strong, we need to protect the data with the need of strong authentication. Okay. So that's why the second challenge is called lack of standardized security protocols. Okay, we have some set of protocols like now we are all using like HTTPS. The port number of HTTPS is 443. Okay. If you're going to discuss the HTTP means the port number is default port number is 8080, right? So likewise, we have n number of security layer, then security protocol, security ports. So with the security ports, we need to configure the security protocol for the particular ports. If not using the security protocols on the security ports, definitely there may be a chance to hack our data from the computer system, or it may be an internet service. Like, so for example, HTTPS, we are all using TLS as well as SSL system, SSL protocol to secure our HTTPS services in the port number of 443. So likewise, we have a different set of protocol ports to protect the ports by using the security protocol itself. Just I am giving some minimum example for each and every protocol, and as well as ports involved on the communication network. Then third one is called insider threats. So this is the one of the major challenges in the automation system. Okay. So in what is insider threat means, it is, if an example, we have an organization. So in the organization we have 1,000 employee. So out of this 1,000 employee, any one of the employee has an authorized user. That authorized user has to insert the device, hardware device. It may be a pen drive or it may be a disk. Nowadays, now we are not using any disk and all. Now we are using like transferring of data through the cables, or as well as we are using the USB ports. Right? With the USB ports, that any one of the employee has to insert the device on this particular system. That in the USB we have some type of virus. That virus will be spread out to the complete 1,000 employee on the organization. That is called insider threat. So previous, like challenge 1 and challenge 2 will be very easy to find out the vulnerability and weakness in the system by using some sort of techniques. But this insider threat we cannot find out easily, because all the 1,000 employee is on the same organization. We cannot find which employee has an insider threats. That is the best example for the insider threat. So I have some case study on this insider threat that I will discuss on the later slide. Then fourth challenge is managing IoT devices and legacy system. Okay, nowadays if you are going to discuss on the automation, definitely the IoT device will be integrated. So we already know. So all the IoT devices are like all the IoT devices are smart contained devices. The devices are not storing that much data, and we cannot give much more security on the IoT device. Okay. So for that, what we have to do? So while communicating the data from one device to another IoT device, we need to authenticate the one system, one message to another message during the authentication protocol. We have a number of authentication protocol to protect the message communication between the one device to another device. So with that authentication protocol, we have to incorporate on the IoT device as well as the legacy system to protect the complete automation of the control system on the control server and the smart grids. This is the fourth challenge. Then fifth challenge is real-time attack detection and mitigation. So we have a SIM system. Okay. In the cybersecurity, we have two sort of real-time attack detection and mitigation. One is called SIM, and one is called SOC. With these two, we can continually monitoring. That is called security information event management system. By using we have a number of tools are there to monitor the real-time attack on the organization. If you take an example, Microsoft means they have a one monitoring system called QRadar. If you spoke about the Splunk, or spoke about the Wazoo, so all those things are the monitoring system. There is some monitoring system to monitor all the information from the one system to another system in the controlled environment, in the automation environment. Okay, so with this is the fourth challenges. This challenge why, because nowadays we are all facing lot of zero-day attack. Okay, so with the zero-day attack, we cannot find easily whether which attack will be attack on the system. Okay, so for that we need a SOC system as well as SIM system to protect, to control, to monitor the complete environment on the single dashboard. That is called challenging 5. Because if you are going for automation, definitely we have a large number of data set, large number of data on our hand. Okay, so with all our data, we have to monitor in 24/7 means definitely the volume of data will be very high. Okay, then it will be a very big challenge to maintain all the data on the particular system. Because if you go for like small organization, it is not required to monitor all the data 24/7. If you go for huge organization or a huge like power grid or nuclear power plant or some other water control system. Okay. So like this, if you go for very big organization or very big industry, definitely we need to store all the data in 24/7. Yeah. So in the situation, we need a real-time attack detection and mitigation, that is called SIM or SOC. There is Security Information and Event Management System, as well as SOC, Security on Control System Operation, that will be definitely needed for control all the system in the single hand. There is a challenge. So these are all the very big or very huge challenges facing in the real world on the smart grid system, as well as other application too. Clear? Sir, is my voice audible? Hello, sir.
Your voice is audible, sir.
Okay. Thank you, sir.
Thank you.
So, dear participant, if you have any queries, definitely you can post it in chat, or else you can note down all the queries by your hand, and you can ask your queries after the presentation. Clear? So next one is the common cyber threats to smart grids. Okay. So previously I am explaining the challenges in smart grid system, and also in different applications. Now I am going to discuss some of the common threats to smart grid as well as some other application too. Okay. So the first one and major threat is malware and ransomware attack. This is the first threat. Nowadays, all the organizations are facing three major attacks. One is called ransomware attack, another one is called phishing attack, then third one is called denial of service attack. So these are all the three basic attacks. These are all three major attacks. Nowadays, all the organizations are facing very difficult to protect all our data from these type of attacks. Three attacks. One is called ransomware, then phishing, then denial of. Why I am saying this three type of attack is major attack? If you go and search in the Google, this three attack will plays a major vital role in all, including Microsoft or Google or some other different organization also too, right? So first threat is called malware and ransomware attack. So difference between this malware and ransomware is, so ransom is nothing but the based on the, because of the requirement of money, the attacker may hack the system. Okay, once the system is hacked, the complete data will be encrypted. Okay, once the ransomware attack is happen on this organization or device, the complete system is taken control of the attacker. Okay, he or she will encrypt all the file on the system or the network. Okay, so once they will demand some ransom, like some money. If the money will be given to the attacker, then only they have to decrypt all the file on the particular system. Okay, if the personal system is, definitely no need to repay the ransom. But if you go for huge organization or huge system or huge like a smart grid or nuclear power plant, definitely they need a data, right? So because each and every data will be very, very important to monitor all the information from the particular applications. Okay, so for that purpose, definitely they need to pay some amount of ransom for the attacker to decrypt all the file from the ransomware attack. This is called ransom. So we have to pay the ransom money. So once the ransom money is paid, then only all the files will be decrypted from their end. Okay, that is called ransomware attack. One is called ransom. Malware is nothing but malicious software. It is like a piece of virus that will affect our system, or after the malware is inserted into our system, the attacker has to capture or take all the data from our system without any information from the particular owner. That is called malware. Okay. Then second one is called denial of service attack. So this is also one of the major attack. Why? Because if you go for complete automation, definitely we need a service. Okay, so without server, we cannot store all the data or all the communication from the one end to another end, right? So with this server, if the server is attacked by some attacker, it may be like a snooping attack or phishing attack or man in the middle attack or APT or like a user administrative attack. Okay, we have a number of different types of attack are there to attack the server, like dictionary attack, brute force attack. So these are some example of the DDoS attack. So with this attack, if the server is compromised by the attacker, definitely they may be possible to gather all the information from the particular server. They may alter the value Okay, if suppose for example we have a power grid. Okay, so once the power is generated, we have to distribute the power based on the some amount of power generated by the generator. Okay, if the generator power, like generator running power RPM is very high, means definitely there may be a damage of there may be a damage in generator to generate in the loss of energy, right? So that control, all the control will be automated by the server. The server data will be controlled monitored by the attacker. If the attacker has to change some value on the server, definitely that will be affected by the organization, that will be affected by the generation of the power. Okay, so this is the best example of the denial of service on the server side. Okay, basically DDoS attack is based on the server side alone. Then third one is called phishing and social engineering. So nowadays this phishing and social engineering is a major attack. So phishing is nothing but it is a unwanted URL. Okay, nowadays we all see like Amazon URL will be coming generated from someone. There may be a transfer to through WhatsApp. If you are going to buy this product by ₹1 by today itself, and like this, some information will be coming through the WhatsApp, right? The spreading information. So all this URL will be a fake URL that is called phishing attack. Once you click that URL, definitely there may be a possible of hacking all the data from the particular device. Okay, if suppose you are sending one WhatsApp message to me, that is unwanted URL to me. If I click that particular URL and I will just once I click the URL, that is enough for the attacker. They may be capture all the information like which SIM you are using, recently which type of application you are using, which browser you are going to use. So in browser, how much cache is involved. Okay. So all those types of threats, all those types of data breaches will be occurring through the unwanted URL that is called phishing. Now, at the end, I will show you some real-time monitoring tool, how they will the data will be breaches from the particular mail ID as well as particular cache. That way we will show you at the last end. Okay. Then third four, there is called APTs, advanced persistent threats. This is also one type of malware by after developing an application, that through the application the attacker will hack all the data. That is called fourth one. The last one is called data manipulation and unauthorized access. So these are all the 5 major threats will be occur on the small grid as well as some other big organization also. Okay, which I am discussed earlier, like a nuclear power plant or Microsoft or like Amazon. Okay, wherever it may be, definitely this 5 challenges will be a very big task, as well as this 5 threat will be a major role which will be played on the different type of applications in the real world. Then, so coming to the case study of smart grid attacks. Okay, so first case study I am going to discuss the Ukraine power grid attack. It is happened on the year 2015. Okay, so in 2015, Ukraine power grid is completely attacked by the attacker. So they targeted the distributed power supply across Ukraine, affected approximately 225,000 customers are affected by this attack. Yeah, this attack is called a ransomware attack. It will be occur on the Ukraine power grid. Okay, so with this attack, 225,000 customer data has been leaked. So after paying the ransom by the government, then only the attacker will decrypt all the customer data to the particular government. Okay, this is the incident overview. Okay, so then now you can realize how much the cyber attack or cyber security will be involved in the current scenario. Like, so this is one of the example. Okay, so with this attack mechanism, attacker used spear phishing mail to deliver malware, followed by the coordination action to disable critical system remotely. Okay, so what this hacker will do through the phishing mail, okay, through the phishing URL, that URL is sent to one of the customer on the particular Ukraine power grid. So he may open the mail. Unfortunately, he may click that URL. Okay. With that URL, he may take all the coordinate actions. With the coordinate action, he may disable the complete critical system from the Ukraine power grid. Okay. So with that only, they may breach the 225,000 customer data on the Ukraine power grid attack. Okay. So what they learn from this attack is the importance of secure authentication. So how we are going to authenticate? Already I said, right, authentication is one of the major play role for the automation system. Okay, so importance of security authentication, then regular audits. Okay, now already I said we have a already like Suresh Kumar said that we have a separate ISO for all the compliances and standards. Likewise, if you're going to protect the information, we have a separate standard called ISO 27001 2022. That is the standard for protecting the information from the communication. Is regular audits, then employee regular training will be given to the employee. Okay, from the it may be a month, or it may be a 2 months once, or it may be at least 3 months once. We have to conduct the awareness training for the particular employee working on the particular power grid to give the awareness, like what are the types of attack will be there, how the attack will be happen. So we have, once the attack is happened, how we are going to protect from the system. So likewise, you have to give the complete awareness training to the particular employee. Right? So this is the one of the best case study for the Ukraine power grid. Then second one is called a STECNET bomb in critical infrastructure. If you're speaking about the complete critical infrastructure, the complete automation of the smart grid, definitely we must know the STECNET. Okay, so the incident, what the STECNET will happen, the sophisticated malware that is called STECNET. The name of the malware is called STECNET. They targeted the ICS system that is called industrial control system, specifically program PLC that is called programmable logic controller, to disturbing the Iran nuclear centrifugals. So this attack has happened on the year, I think 2010, I think so, May month 2010. So this attack has happened on the nuclear power plant. So the attacker will control the centrifugal rod of the nuclear on the nuclear power plant. Okay, the centrifugal rod will be run on the particular RPM alone. If the centrifugal pump RPM is increased, definitely the complete power plant will be destroyed. Right? So like that, the attacker will hack the complete physical system to control, to take a control of the nuclear centrifugal pump, to increase the speed of the RPM, to destroy the complete nuclear power plant. If you go and search this Iran nuclear centrifugal attack by using STECNET, means that will give the complete information how the attack will be happen. Okay, that will be available in the Google. If you want, you can go and search. Okay. So if you are in the complete automation, we must know the hardware and software, how the communication will be involved from the one end to another end, or one hardware to another hardware. So everything you have to know. Then only we have to give the protection measure to protect the complete system. Right? So the attack mechanism, listen here, the delivered via the USB drive, the STECNET exploit the multiple zero-day vulnerability to spottage the critical operation without any detection. Okay. So after the attack happen on the Iran, the security professional, they will not capture that, they will not detect the attack on time. It will take some month to detect how the attack will be happen. Okay, if the attack is happen on the some other big infrastructure, then they will write some mitigation strategy to protect the STECNET attack from the different applications. This is the attack mechanism. Then relevance to the smart grid. So I will show you some example like previous what I am said. So that I will explain the later slides. So the key lesson they will learn from this STECNET is importance of securing ICS, that is called industrial control system, patching vulnerability, and isolating critical system from the external network. Okay. So if you all, I hope you are all using smart mobile phones, right? So you may notice that sometimes it may give some notification on your system. The security update, the security patches will be there on the system. You can click this and you can download the patches and you can update the system upgrade. Okay. So after downloading all the system, you can open the complete description. They may show definitely the security patches update will be there on the particular update. Okay. So completely they are going to update the vulnerability and patches on the system. Okay. So likewise, you have to patching the vulnerability, then isolating the critical system from the external network once the attack will be happen on the system. Then third one is called insider threat in utilities. So this one of the best attack is for the insider attack is, I think, 2021 Colonial Pipeline attack. May 21, I think so. So colonial pipeline attack will be occur. So with that attack, the attacker, there is the name of the attacker, I think so, Dockside attack. Attacked the colonial pipeline and computerized equipment. The attacker stole and locked up the complete company data, forcing the pipeline to go offline. So hacker demand a ransom of, I think so, 75 Bitcoin, which is worth of $4.4 million at the time. So what the attack is, the attacker, the once the attack has happened on the colonial pipeline, the 13 states and the nation capital, the colonial pipeline carries 2.5 million barrels of gas line and jet fuel per day, supported by 45% of the East Coast fuel supply. So they will block this much amount of barrel of gas line as well jet fuel per day with this colonial pipeline attack, which is happened on the year 2021. Yeah, that is purely based on the ransom. So likewise in 2019, the former employee of Ganesh Water Utility has charged with tampering with the water treatment system by shutdowning system controlled remotely after the treatment terminated, after being terminated. So once the employee is terminated from the particular employee, definitely you have to block all the credentials, all the mail information for the particular employee. If not, definitely this may occur on the particular organization. Okay. So what the key lesson learned from this type of insider attack is, first one is called enforce the strict access control policy. That is called ACPs. Okay. Access control policies. The second one is called regularly audit user privileges. The third one is called implement a rapid credential revocation protocol for departing the employees. So once the attack has happened, how we are going to mitigate the strategy and what are the best practices we can do for the protecting this type of different type of attacks. First strategy is called, you have to deploy the multi-layer defense mechanism. Like we have a different type of authentication factor. One is called one-factor authentication, two-factor authentication, and multi-factor authentication. So likewise, we have a number of different type of authentication mechanisms are there. So with the different type of layered defense mechanism, we have to configure on the particular system. That is called first strategy. Yeah. Second example for this multi-layer defense mechanism. So we are all using Gmail, right? So nowadays we are all using two-factor authentication for Gmail. Yeah. So there may be a different, totally we have two different keys. One is called public key, another one is called private key. Okay. So if you are going to enter your mail ID, that is called public. That is mail ID is called public key. Okay. If you are going to enter your password, that is called private key. That private key is not known to public, right? So, but the mail ID is known to everyone. Okay. Once if you are entering into the third party system or third party laptop for the mail ID as well as password, that is by using the public key as well as private key, definitely there may be a notification from your mobile phone that indicates that some other the third party will be trying to log in your mail ID. Okay, right? So that after notifying that notification, we have to select yes, I am in. Then only the Gmail has to enter into the particular system, right? That is called defense mechanism, multi-layered defense mechanism. That is called two-factor authentication. Nowadays, most of the application, most of the organizations are using asymmetric key cryptography. That is called different type of encryption algorithm are there to protect the data on the different layer mechanisms. Okay, that is called first strategy. Second strategy is called secure communication protocol. Already I said we have totally 65,535 ports are there. So out of this ports, we have to protect all the ports by using some type of secure communication protocol. Okay, example I said HTTPS, right? So for HTTPS, we are using the protocol called the SSL protocol, secure layer protocol. Okay, so to protect the exchange of data from our system to the server. That is called second strategy. Third strategy is called regular security audits as well as penetration testing. This is the way nowadays all the organizations 2 months once they are doing the regular audits as well as the penetration testing for entire server, then website as well as the banking application too. Yeah. Then fourth strategy is, as I mentioned earlier, we have to give the regular training to the employee as well as awareness. Okay. So how the attack has happened. Once if attack has happened, the employee will not be panic. So once the attack has happened, how we are going to isolate the system from the particular network? That is the first step we are going to take once the attack has happened on the particular system. Okay. So likewise, we have to give the regular training. Okay. It may be a monthly or it may be at least 3 months once. We have to give the regular training to the corporate employees. Okay. Then fifth strategy is advanced monitoring system with AAML. So that, as I said earlier, we have a number of SIM as well as SOC tool to monitor the complete system on the real-time environment by using the AA as well as ML. Because nowadays all the complete system will be monitored by, controlled by the AA and as well as ML. So example, if you go for Microsoft, they may have a QRadar. Yeah. Then if you go for Google, they may be a Sentinel to Microsoft. They may be a Sentinel SIM tool. Likewise, we have a number of tools are there to continuously monitoring the system on the by using the AI as well as ML. Then the role of emerging technology in securing the smart grid. So these are all the research areas we have to focus to protect the smart grid system. One is called blockchain for secure transaction. Okay, first one. Second one is called artificial intelligence for threat detection for complete automation system. Third one is called IoT security framework. Then fourth one is called quantum cryptography. So these are all the four major areas, research areas. We have to focus to protect the complete automation system. It may be a smart grid or it may be a nuclear power plant. It may be some big organization too, right? So first one is called blockchain for secure transaction. Second one is called artificial intelligence for threat detection. Then third one is called IoT security framework. Then last one is called quantum cryptography. So these are all the four major area we have to focus. We have to focus the research for protecting data on the complete automation. So these are all the coming slides are going to show the importance application and important threats are there to affect the smart grid. So first important application in the smart grid is called. So these are all we all already know because we're all in the complete real world scenario applications like advanced metering infrastructure, SCADA system, electric vehicles charging, then demand response management, so outrage management, distribution management, then home energy management, then last one is called access management. So all those are the important application of the smart grid. So these are some type of attack on the communication layers. As I said earlier, we have 7 layers for transferring of data from one medium to another medium, right? If definitely the information is exchanging, these 7 layers will be involved directly or indirectly. If the 7 layers are involved, definitely there may be a possible of attack, right? So if suppose for example, if we take an application layer, the application layer means if we are all using browser for exchange of login to Gmail. Okay, we have a Chrome browser or Mozilla Firefox. So to log in into the Gmail, or it may be a Gmail application. Yeah. If the application is involved, definitely these 3 type of attack may be involved. One is called flooding attack, social engineering attack, then another is called intrusion attack. These 3 attack may be possible on the application layer. Then if you go for presentation layer, the brute force attack will be occur. Then if you go for session layer, the man in the middle attack, then brute force attack will be possible on this third layer. Then transport layer means injection attack. The network layer means so jamming, spoofing, injection, man in the middle, eavesdropping, floating, intrusion, brute force. So all these attacks are comes under the network layer because we are all sending the data through the IP address, right? So without IP address, we cannot exchange the data from the one layer to IP. Another layer, we have 2 type of IPs. One is called IPv4, another is called IPv6. So IPv4 is a 32-bit, IPv6 is a 128-bit. So with these two, IPv6 is a secure when compared to IPv4. That already we all know. So if you are going for big, huge organization, they are all using IPv6 IPs to protect the complete network for exchange of data between the one layer to another layer or one medium to another medium. Then the next layer is called data link layer. If you're speaking about the data link layer, we have a different type of attack like jamming, spoofing, injection, and time synchronization. Then if you go for physical, then if you're speaking about the physical, they have 2 mediums. One is called wired medium, another is called wireless medium. Okay, if you're speaking about the wired medium, we have different type of cables like optical cable, then transmission cable, then coaxial cable, then twisted pair cable. Like this, we have a number of different type of cables are there to exchange the data from the one medium to another medium. So likewise, what type of medium will be involved to carry the information from one medium to another medium? With this medium, we have a number of attacks. One is called jamming, spoofing, then like time synchronization attack. Okay, so these are all the overall view or overview of what are the types of attack may be possible while involving the exchange of data from this one device to another device while involving this OSI layer, right? Then classification of detection techniques in smart grid. So all these 6 detection techniques are very vast area. So okay, just I will give you the technique. What are the techniques are there to detect the attack on this smart grid? Okay, so one is called localization based technique. Another one is called AI based technique, that is based on ML and AL. And it's called prediction model. Then channel characteristic based. Then filtering based. Another one is called intrusion detection system. Okay, so we have 2 systems. One is called IPS. Another one is called IDS system. So with this, both are comes under this IDS IPS on the intrusion based detection system. So these are all the some of the countermeasures. Previously I discussed some 5 types of mitigation technique. Likewise, how we are going to countermeasure the attack on the smart grid system. So basically, we have 2 different categories. One is called preventive, one is called proactive. Okay, so the preventive and proactive, these both are completely different. With this preventive, what are the types of techniques are involved to protect the data from the preventive based? What are here I am showing in the blue color as well as green color. So secure protocols, which I discussed here, like secure protocol, authentication, intrusion prevention, then given training to the employee, then access control and privacy security policy. So all those things are comes under the preventive based. Yeah. So protective based means spreads spectrum techniques as well as gaming theory based. So these are all the different type of classification of countermeasures in smart grid environment. So these are all these references, and I will end up with this thank you slide. Hello, sir.
Sir?
So I completed my presentation.
Okay,
If the participant has any queries, they may ask now.
Dear participants, if you have any queries, please post your questions through chat box.
So before that, I will show you how the attacker will breach the data through our mail ID. That I will show you on demo. Just a minute. So is my screen is visible, sir?
Yes, sir.
Hello,
Visible,
sir.
sir. Visible, sir.
Oh, okay, sir. So one tool is called Have I Been Pawned. So this is the website. With this website, we can see whether our mail ID has been breached by someone or not. So once if the mail ID is breached, where the data has been leaked, what type of data has been leaked, that and all we can know from this particular tool. This is called Have I Been Pawned. I will give you some random mail ID like just I will give you some random mail. This is my friend mail ID at gmail.com. Okay, if I give this will give some information about how the data has been breached by through this mail ID. Okay, here we can see now pawned. This is pawned in 4 data breaches. Pawned in 4 data breaches and found no paste. Okay, so only they have taken the data. Okay, from the from the particular mail ID. Okay, clear? That I will show you where the data has been leaked from this particular mail ID. Here we can see. So one is called LinkedIn. Okay, first one is called LinkedIn. In the year 2016, some attacker may breach the data from the particular mail ID through the LinkedIn app. Okay, so they may compromise. What type of data they may compromise is email ID and password. Email ID and password. Okay, if you see the second one, data enrichment exposure from PDL customer. In the year 2019, from this, the attacker has breached some data. So what type of data has been breached means email address, employers data, geographical location, job title, name, phone number, and social media profile. Right. So next one, if you see this, Domino's India in the year 2021. Okay, through this app, that the customer has registered through the particular mail ID by accessing this Domino's Pizza app. Okay. With that particular app, the attacker may breach the data like email address, name, phone number, and physical address and purchase order. Okay, then not SO or radar. Okay, so in 2024, okay, so this is like a security system operation center. Where the mail ID has been breached through this not SO or radar in the year 2024 August. In recently, this is recent. So likewise, we can see from this tool we can see if our mail ID has been hacked by someone or not. Likewise, how the data has been breached, where the data has been breached, which type of data has been breached through the particular mail ID. That and all we can check through this tool. That is called Have I Been Pawned. So for avoiding these breaches, we have to ensure this three-step for better security. One is called protect yourself using one password to generate and save strong password for each website. We cannot use the same password and user ID and password for all the website, all the app. Okay. Definitely we have to give the password and username randomly for the each and every website, every application. This is first step. Second step is enable two-factor authentication and store the codes inside your one password account. This multi-factor authentication. This indicates the second step indicates the multi-factor authentication. Third step, we have to randomly have to change the password. It may be a 3 months once or it may be a monthly once. That password may be a combination of characteristics, numbers, as well as the special characteristic. Clear. So likewise, we can protect our mail ID, our data from the different type of attacks, which I discussed earlier. Like, okay, so this is one best example how our mail ID has been breached by someone. We can see, we can use this tool, we can see, we can visualize how our data has been breached from the particular mail ID. That we can easily visualize from the tool name called Have I Been Pawned. Okay, so likewise, we have a number of tools are there to completely visualize all the data. Okay, clear. But now we have no time to discuss all the tools. Okay, clear. So now previously I can explain you like SIM and SOC. Okay. Nowadays all the organizations are using the SIM and SOC to incorporate the complete monitoring system on the one dashboard, right? So up to this, I will stop my session. If you have any queries, you may ask now.
Dear participants, if you have any queries, you can post your queries through chat box. I repeat, dear participants, if you have any queries, you can post your queries through chat boxes.
At least response through chat itself.
Yes, sir.
So I hope everyone understand what I'm explaining, sir.
Yes, sir. Yes, sir.
Okay, okay, sir. Okay. So thank you, ma'am.
Any queries, participants? Okay, sir, shall we wind up, sir?
Yes, sir, we can.
Libika?
Vote of thanks. As we draw close to the end of the session, I would like to extend a heartfelt gratitude to Mr. Gomadi Shankar for taking the time to enlighten us with his profound knowledge and expertise. Your journey of excellence and the invaluable sights you shared today have inspired us all. We deeply appreciate the effort and dedication you have put into mentoring aspiring engineers and contributing to advancements in electrical engineering and automation. I would also like to thank our institution for making the session possible. A special thanks to our audience for your active participation, which added energy to the session. Let us continue to take inspiration from professionals like Mr. Gomadi Shankar and strive to achieve new heights in our respective fields. Thank you all. Now I call upon Dr. Jay Shiva to deliver valedictory address for the 6 days AICT Atal sponsored faculty development program.
Yes. Before that, Gomadi Shankar sir, it was a very nice session and very useful information. Even unknown information were shared. Excellent session, sir. We would like to felt our hearty felt thanks to all of you.
Thank you, sir. It's my pleasure.
And especially the last demo that you have shown was amazing, sir. Even we have, no one of us have known that particular website and all, right? And you have said all those things were very informative, sir.
Thank you very much, sir. We have a number of tools are there, sir, but there is no time to discuss everything. That's
Yes.
why I plan to show one tool to hack the mail.
Yes, sir. Very, very informative, sir. Thank you, sir. Thank you for your wonderful information, sir. The session was really nice, sir. Thank you, sir.
Thank you, sir.
Thank you, Gomadi Shankar sir, for your wonderful presentation today.
Thank you, sir.
And dear participants, we have came to the end of our 6 days Atal Faculty Development Training Program. And with this thing, I would like to deliver the valedictory note for AICT Atal sponsored 6 days Faculty Development Training Program on Next Generation Smart Grid for Sustainable Power Systems, the path from Industry 4.0 to 5.0. And this program is being conducted between this program is scheduled between 2/12/2024 to 7/12/2024. And during this period of 6 days, we have embarked an enriching journey delving into the cutting-edge realm of a smart grids, a domain that is crucial to our sustainable power future. As it is to be the evolution of the technology and societal welfare being, this program has brought together some of the brightest minds from academia and industries, fostering the discussions that will be undoubtedly shape our understanding and contribution to this critical field. Throughout this program, we have explored the intricate interplay between technological advancements, sustainability goals, and the paradigm shift from Industry 4.0 to Industry 5.0. During this period of 6 days, the various topics being discussed by various resource persons are from the topic of advanced IoT solution for smart grid monitoring and control, and the role of smart grids in sustainable energy management, and artificial intelligence and machine learning application to the smart grids. And while coming for cyber security issues, we have also addressed the area on cyber physical systems and power engineering. This will be the bridging gap between the Industry 4.0 and 5.0. And we have also gone across the future of smart grids beyond the automations. And coming to the renewable energy sources, which is the major aspects in the smart grids, we have also gone for the integration of renewable energy sources in smart grids and human-centric artificial intelligence for Industry 5.0 in power systems. And we have also discussed the topic on policies and the regulations for developing a sustainable smart grid by integrating the circular economy principles in the power systems. These are all the topics which we have covered during the past 5 days. And today we have discussed about the digital twin technology and smart grid operations, which is being delivered by Kinde Anlifante, who is a foreign resource person from Jimma University of Ethiopia country. And second session is being provided by Suresh Kumar, Deputy General Manager in Schneider Electric System. He has delivered the topic on designing resilient power system for future industries. And at last, this is the last most session, cyber critical challenges in smart grid systems. This being delivered by Mr. Gomadi Shankar, Siemens Gamesha, Bangalore. With this thing, I would like to extend my heartfelt gratitude to all the distinguished speakers and resource persons who have given generously shared their expertise on their field in spite of their busy schedule. And a special thanks to be mentioned to AICTE Atal for giving me an opportunity to organize this FDP, to all the faculty members as well as the industry persons. A special thanks to the we mentioned AICTE Atal for giving me an opportunity to organize the faculty development training program on the above topic of next generation smart grids for sustainable power system, the path from industry 4.0 to 5.0. And I also would like to thank the management of Sri Krishna College of Technology, Coimbatore, for giving me an support, and the principal, Dr. M.G. Sumitra, and head of the department, Dr. Lijo Jacob Varghese, and the faculty members of AAA department for their meticulous planning and executing this program. Last but not the least, a warm thanks for all the participants who have joined from various academic institutions in spite of their busy schedule by sacrificing their family commitment in the evening. Thank you all once again for the dedication and participation by supporting. Wishing you to continued success in your professional and personal endeavors. Let us continue to illuminate the path to a smarter and more sustainable future. Thank you, one and all. Thank you. Lipika. Okay, dear participants, please complete the feedback. The feedback links are active. The error has been rectified. The session 1 and session 2 has made active. The feedback link is active now. Please fill the feedback forms, and the feedback link for the third session will also be posted again. And the assessment exam, which is the mandatory for validating your presence, will also be shared as a Google form. Please complete all the feedback links so that we can able to complete the attendance on time, as well as complete the assessment exams before 10 a.m. tomorrow. If you are not able to, if you feel any problem in opening the link, please contact me. Thank you once again. Thank you all. The presentations of all the resource persons will be shared as a Google Drive, and all the materials will be shared in the Google Drive. You can please access all the things. If any of the participants have changed their mail ID, please message me so that I can able to connect the link to you. Why? Because I'm receiving some delivery note saying that delivery failed, like that and all. If you have changed your mail ID in AICT after attending the program, please send the mail ID also. Thank you all. And dear participants, the feedback link for the third session along with the assessment question is also posted in the chat box. Please make a copy of it and complete the assessment exams before tomorrow morning. The feedback form will be available till tomorrow morning, and you can complete the assessment by tomorrow till tomorrow evening 5 p.m. I repeat, you can complete the assessment questions by within tomorrow 5 p.m. and complete the attendance form before attendance link by submitting the feedback before 10 a.m. tomorrow. Thank you all.